special interest is not One Piece, it's baking, but he does watch anime, so he would be into One Piece. And he forces me to speak Dutch. He screams so it was crazy. It was like the more the evening went on, the more I was like, you're everything else. And then I was like, what would I do? And now I have this crazy plan to make him to.
Guys, come open!
Woohoo! But yeah, then I knew someone else who was actually really strong. But he said so right now, so he said all didn't know anyone, and said a little bit awkwardly.
The whole line that was over here is for people going to the bathroom. I thought they were waiting to go inside. Oh, guys, I've never seen that before.
I mean, yeah, it's crazy, right? All of them are waiting for the guy to.
Ça, bye bye. Et vous programmez que nous sur papier, qui nous commandent des jeux, c'est très bien, tous les jours soirs. Il y a des déchets.
Good luck, guys. Gewoon uit first principle probeer te bepalen hoe het nou
als je niet hard zou doen, your turn.
Ja, maar dit is nooit kosten. Ja, gisteren heel veel.
Maar is de geval voor deze is
Ducks to ducks. Nothing else, only the ducks.
I don't bring a lot of friends to you guys, but I know for a fact we did the same. Yeah, that's good. So ground floor is yeah. Yeah, that's okay. Yeah, thank you.
Yeah, exactly. I'm right on the wall. Oh, I've started to do the most I've actually done. Tim has revealed to me like when I was his kitchen that the chalk on his arm wall. So I've been chalking the wall. It's fine. It's literally just chalk. It's smooth. So I can just wipe it off. Yeah, it's psycho. He's gonna think it's really cool. He's gonna think it's cool. Oh yeah, babies do that. Yeah.
Special needs. Nee, die hebben we weggehaald. Die waren gewoon op. Ik kan een stil met ja, graag. Oh, dank je.
Oh, that's so. Such. I'd be doing that all the time. I like David's one as well. Right. I just want to take no apologies. Yeah, there'll be like one question. Me too. I'll be surprised. Sometimes I reluctant. Sometimes I pull stuff out of my ass. You don't know what theorems I derive from smoking myself. But sometimes I do. No, but I made it right. I know.
wait a minute. Yeah, now it works.
Okay.
Hello, everyone. Once again.
Yeah, good morning, everyone. We just started our NWERC 2024 edition here in Delft University. Everybody already started working on problems, so join us to have a great discussions today. We will discuss problems, maybe some solutions a little bit later on, and have some great interviews. For example, right now I'm joined by none else, by Nikolai Budin, Grandmaster, third place
Yeah,
in
thank you.
ICPC World Finals, silver medal in IOI.
Yeah. Well, that wasn't the brightest page of my life, but yeah, still quite a good result. Yeah, we will look after teams, how they try to solve problems. Well, and of course we will discuss problems, we will discuss solutions. Unfortunately, we have to wait a bit for that. So now you can consider that like a, morning show on your TV. You can make yourself a cup of coffee or tea, and yeah.
Yeah, I think for the first minutes of the contest, it's usually a bit of quiet. Everybody is reading through the statements. We can already see in a scoreboard, which is, I believe, publicly available, that there are M problems. So it's like 13 of them. It's half of the whole alphabet of letters.
Yeah.
I don't know, maybe some year. I don't know.
So many problems this year.
It looks like each year it's more and more. So maybe at some moment of time, I don't know, jury just ran out of letters, not know what they will do in such case. So yeah, but I don't know. I will expect that some top teams should be definitely ready to solve something in like 10 minutes or so.
Yeah, usually first problems are solved quite fast. Sometimes it's even less than minutes, but yeah, sometimes it takes a bit longer.
Yeah, especially today when, like, in contrast to the yesterday test session, as teams said us that like 20 minutes of penalty, they basically mean nothing because it's a test session and it doesn't matter if you win or lose. But here you definitely want to be a bit more careful.
Yeah, but there are still different tactics. First of all, of course, you need to read all the problems. And since there are so many problems and you have 3 teammates in your team, you should divide that problems between people so that you can find easiest problems as fast as possible. When I was participating, we decided with my teammates who will read from the beginning, who will read from the end, and who will read the middle part. And yeah.
Sorry to interrupt you. We just got our first accepted for the problem A, if I see it correctly, and several incorrect submissions for the problem E, I suppose, or only one. But yeah, is the team from Cambridge University, the Unity. It's basically, I think it was the top 1 team during the UK preliminaries. I'm not sure if the same team participated previously in NWERC because they either changed names or it's completely new team, but definitely University of Cambridge is one of the top universities at NWERC. They usually have pretty great performance, and they had a bronze medal just in 2023 ICPC finals and 35th place on the last World Finals.
Yeah.
So definitely one of the today's team that could be at very, very top. And it's a great start for them from the first try solving the problem.
Yeah, and also when you start, you nervous quite a lot. And then when you successfully solve the first problem, well, it gives you some relax, you calm down a bit, and you continue in a good way. Much worse if your first submission is incorrect.
Yeah, that's right, because when it's first minutes of the contest and you are trying to solve something and then you get a wrong answer, it means that you just got a 20 minutes penalty time.
Yeah. Well,
just on the start.
That is even not the worst part, 20 minutes is quite... It can cost you first place, for example, but still the more important that it's just start of contest. And if you spend, let's say, 5 more minutes in that moment, every following problem will be solved 5 minutes later. Well, of course, that is not completely true, but yeah.
Yeah, I agree, because like it's kind of difficult to decide what to do, because like in the start of a contest, you maybe have a lot of ideas for the easiest problems, and then you submit, got wrong answer, and you don't know what to do. Should you pass the computer to your teammates, or continue working and spend more time?
Yeah, usually when there are more solved problems, we I or one of my teammates left computer, maybe printed solution, and let other teammates to write the next problem.
Yep. I said that, like, obviously it's a good approach, but in the beginning of a contest, you're like, oh, I just need 1 more minute. It should be something easier. Well, we still have a lot of teams that, not really a lot of, but several teams that are trying to solve problem E. I think it's more than one right now, and more teams are solving problem A. Oh, we actually have a first successful submission for the problem E.
Yeah.
Which is kind of unexpected, to be honest.
Solve that.
Because it's Chalmers University of Technology. I think. No, it's another team. It's the second team, actually. Both of the teams from Chalmers University of Technology are trying to solve this problem. And the funny thing is that yesterday we had on our interview another team from this university, and they said us that they want to beat all the teams from Sweden, from NCPC, and be the top team from the sub-region. But actually, it looks like right now they are beaten by the second team of the university. So it would be interesting battle to watch.
Yeah.
I also wanted to say that, just to quickly explain a bit, I don't know, maybe we are joined by some friends or parents of contestants who are not really familiar with ICPC rules and ICPC style contests. So basically, we have around 80, I believe, teams, which consist of 3 contestants, and they have only 1 computer and 5 hours to solve a set of 13 problems. And basically that's it. So it's not only a challenge to come up with solutions and implement them and submit them, but you also need to think about how do you spend time on different issues, how you manage the teamwork and stuff like that, consider strengths and weaknesses of your teammates. And also we mentioned several times the penalty time. So the final ranking, it's sorted not only by the amount of problems solved, it also depends on how fast you to solve them. So basically your final score is the amount of problems you solved, and then secondly, the second priority is the total time you spent on solving the problems, which is basically just the total sum of the number of minutes when you submitted the successful submission.
Yeah, plus penalty time for incorrect submissions.
Yeah, plus 20 minutes for every incorrect submissions, but only for problems you solved. So if you tried to solve something and it didn't pass at all, then you're not penalized anyhow.
Yeah. And we got first team that solved 2 problems.
Yeah, it's actually also from the University of Cambridge. But it's another team which wasn't the first.
Yeah, that would be fight. And also it tried to solve problem B.
Yeah, which is also kind of interesting.
Yeah, we will discuss problems later.
Yeah, but actually we just got news that maybe they just messed it up a bit and sent the solution to problem E to the problem B. You know, it's sometimes a bit tricky to, but you're a bit nervous maybe, and shaking hands and you can submit some solution to the wrong problem. It will be not very good in the end of the contest.
Well, let's hope they won't try to solve that problem during the contest, so they won't get additional penalty for their submission. But on the other hand, it's better. It's strictly better to solve more problems.
Yep.
So let's hope they solve it, and they don't have to care about penalty time.
Yeah, it's actually interesting. We have a lot of teams from each preliminary that are solving problem A, and already 3 teams that solve problem E, or even more. No, it's already like at least 5 teams. You also can see right now on a stream that the teams are rewarded with balloons. So it's also an ICPC tradition. When you solve each problem, you get a balloon with the color of this problem, so everybody can see who solved which problem.
Yeah, and interesting question: how do they decide colors?
I don't know. Do you know?
Well, I've heard that usually organizers ask jury members about the most difficult problem, for example, to give it black color. Maybe some couple of other colors are chosen, and all other, I believe, chosen randomly.
Does it mean that because we don't have a black color today, all problems are solvable?
Yeah, probably.
Actually, I also just thought that the fact that team from the University of Cambridge, which should be probably like one of the good teams participating today, will be fight for the first places. They submitted problem B. Could it be kind of a bluff for other teams? Because now all of the teams, they're looking at that, okay, what should we solve next after A and E? And they see that one of the top teams submitted problem B, so they can think that, okay, maybe there is some easy idea which we don't see, they would spend additional time.
Yeah, that might work, but I don't think that in that case it will. Because, well, in the beginning you still write what you can solve, what you already solved. And then later, after you solved all easiest problems, you start thinking what to solve next, and then maybe you will look at Scoreboard, but in that time I believe it will be clear if it's solvable problem or not. I don't think you should start to solve problem with one incorrect submission. Maybe if there are a lot of incorrect submissions from different teams, that could say something, at least that problem is harder than it seems to be. But yeah, I don't think that one incorrect submission will change anything.
Yeah, it also probably like would affect different teams differently, because if you are one of the like top teams who are confident in their strengths, they will just solve whatever they like.
Not only confident, but also when you're on the first places, there are no problems that someone solved and you didn't. So you need to choose next problem by your own anyway.
Yeah, it's also like an interesting moment. I also remember that from like my participation in a ICPC style contest, that at some moment of time you reach a level when you are the team that opens the problems. And that's a moment that you're like, okay, and what should we do next?
Yeah, now you don't have that help from other teams.
Yeah. Because actually, like, the scoreboard is obviously a helpful thing, but it's also kind of good because sometimes it could be misleading.
Yeah.
And if you're one of the top teams, like, you look at it for the first time, I don't know, 3 hours into a contest, and you're like, oh wow.
Yeah. Well, if you know well your other teams, then sometimes that might help. If you know that some team has a really strong mathematician, for example, and you see that they solved some problem which no one else solved yet, that means probably that is some kind of math problem. Yeah. So teams continue solving A and E. Now it's already 9 teams.
Yeah, we can see in the top various teams that we also had like today on the interviews, like Sekvaldko Brr from the Delft University of Technology, or the teams from KTH, Royal Institute of Technology from Sweden, who are somewhere near the top, and they're pretty fast to solve those problems. And other like teams from Karlsruhe Institute of Technology and other German universities, like a lot of teams. So we have this year not more than 2 teams, I believe, from each university. So those guys are clearly the ones who go on the top at their local preliminaries. So I believe, I don't know, like maybe average level of teams this year kind of closer than in previous years. So maybe we will see more teams with similar amount of problems. And that's why maybe also the penalty time would be important to decide who will qualify.
Yeah. Well, you know, if there are several teams from one university, that might be harder to
qualify.
Yeah, to have better result than another team from your university, then to take place in the top of
Yeah,
contest.
I know.
Yeah. And sometimes it happened that, well, everybody expected one team to qualify, but eventually they did not so well, and another team qualified. And we have submission problem D.
Oh,
Yeah.
that's interesting. Actually, yeah. See, we can't spoil our problems for now, but
Yeah, but that is team from Delft University.
yeah, it's one of the top teams. I think they were top one at the BAPC, the preliminaries contest. It's also their. I can tell you a bit more about them because we had them on interviews yesterday, and actually I had them on interviews 2 years before. So actually, it's their 5th participation. It's kind of last one for them, last try.
So that is the same team for 5 years.
Yeah.
Exactly the same.
Yeah,
That's amazing.
I think so.
I never had that.
Yeah, it's a kind of rare case because sometimes people.
Yeah, and they solved problem D.
Nice,
By the way.
That's great.
Yeah.
Yeah, they are one of the leaders, and they actually told us that they have much more practice in this year. They had a training contest each Thursday and put a lot of efforts on their teamwork because they work consistently on the top during BAPC each year. So they were one of the top teams from the Benelux region. But then they fail each NWERC they participate in, and this year is the last.
So
try.
they never qualified for World Finals.
Yeah,
That's unfortunate.
but then today is their hope to qualify.
Yeah, well, let's cheer for them.
Yeah, I think it's been a while actually since we had a team from Netherlands at the World Finals. So it would be nice if some team would qualify.
Do you think that participating in the contest in your home university, in your university, helps?
Don't know. I think it could. I'm sure it could if it's the first time and you feel more comfortable.
Yeah.
But when it's the 3rd time in a row, I would say that we are looking forward for the next year and having the NWERC at Karlsruhe Institute of Technology, because I believe that while the organization here is great and University of Delft is doing an amazing job, I still believe that when you are young and participating in contest, you want a bit of travel.
Yeah, you actually do. Well, when I was a school student, I was looking at ICPC World Finals, and I wanted to participate in it and to visit different, countries. And well, when I participated, a set of countries was not so interesting for me, unfortunately.
And we will have a short break. Right now we have one submission for the problem L, which is interesting to see. Oh, it's actually accepted. It's a team kindergarten time limit from Karlsruhe Institute of Technology, one of the top teams from GCPC. But we will discuss more on it later on. You can see them. No, it's not them. Right now we're seeing a team from the Chalmers University of Technology, I believe, on our screen. They're trying to implement something. But we will have a short break right now, so stay tuned and we will come back with more insights a bit later. And welcome back, everyone. We are now joined by our first today's guest, the coach of the teams from Leiden University. So tell us a bit more about yourself, about your preparations, about your teams. What is your expectations?
Right. So this year we have brought only one team, of course, since the NWERC is very small this year. So this team that we have, Team Wormholes, is we're the winners of our local round in the LKP, and also in the BAPC we have had the best performance. We have had it with Leiden since the years I've started coaching, so since 3 years. So I don't want to pressure them, but I really would like to go to Porto with them. Yeah. So I feel like they're doing pretty well. I think they've already solved 2 problems, which I'm very happy about.
Yeah, that's really nice. It was problem A and E. So yeah, looking forward for the next problems that they would solve. We now have opened problem D, H, and L. So there are a lot of things.
A lot of choice
to work on. Yeah. So basically, you said that you are a coach for the 3 years. Now it's the best result this year for the 3 years. So the results are definitely improving. So what's your secret?
A secret. So this year we've started with a more intensive training procedure. So they usually we just leave them to themselves, so that the coaches really work on all the side things, so they don't have to worry about that. And now we have shared a lot of resources with them that we use. We also use our training documents, have been perfected over the last few years. I feel like those kind of things help to let them perform as best as they can.
How often do they train?
So they have been training now for once a week, I think.
Okay.
Which is intensive enough to have a lot of...
Yeah, that's quite a lot. It helps to maintain your level.
Yeah, but I still wanted them to also be able to focus on their studies. So
Yeah, that's important too.
There has to be a balance there.
It's actually interesting because I think we also had several teams yesterday, and everybody was saying like they put more efforts in it and like have consistent trainings and working on teamwork and stuff. So it looks like, I don't know, teams starting working on it more seriously or putting more efforts like year to year. So why do you think it's so? It's like the popularity of ICPC is growing, or just people start to be more serious about that?
I feel like it's interesting to see that everyone, even at Leiden, usually work with a pretty small group with people who compete from us. And this year, I think I have never seen this many teams compete in our local round. And I feel like it really reflects the way that it has been promoted, that people are enthusiastic about it. And I feel like it's a trend that's going up, with more and more teams being interested in this, and therefore also better and better teams being able to go to the NWERC.
That's cool.
Yeah, that's great.
So we have each year more problems, 13 now, and better teams. Yeah. How many time passed? Oh, unfortunately, we still cannot discuss problems. But like, I know. Have you participated yourself in NWERCs?
Myself, not now, but usually I compete in the spectator contest with a team of coaches from all over the Netherlands. We usually perform pretty decently, but I have my own experience within NWERC. Mostly, I've been on juries of our local rounds, and I've been with all the coaches. Mostly.
So it's like you became more interested in like the contests after you finished studies?
Yeah, that's right. So I've done a board year with my association, and from there I've been involved with a lot of the local stuff, especially. And seeing people being enthusiastic about it and having a lot of interaction with people and seeing the hype made me very interested in working a lot with NWERC.
That's cool.
Yeah, and also I wanted to say that it is quite interesting fact that we have not only students teams on NWERC, but also we have sponsors teams and jury members teams that solve problems at the same time, and yeah, it's quite interesting to look after them too, to see how they participate.
I think it's usually interesting that even though you'd expect that the companies, or well, I'd expect that the company teams have way more experience with problems like these, they usually don't perform much better than the student. I think it's interesting to see.
Yeah, usually, well, they don't have so much practice anymore. Even if they used to participate in Olympiads when they were students, now they work, they don't have so many free time, and yeah, they can't practice so often, so yeah. It's also a very important part of a good result. But, well, I hope this year results of sponsors teams will be better. Actually, I know quite many people who participate in sponsors teams. I know 2 people from JetBrains team and 2 people from Jump trading team, and all of them are from my university, and they were, I think all of them were World Finals champions in their year, so yeah, that probably will be quite good results for them this year.
Just a small update from the contest right now, sorry guys to interrupt, but we actually had a problem H opened, I think I already told about this, but we also have a submission for problem F from one of the top teams from the Delft University of Technology, and maybe it will pass and it will be the first solution. Yeah, so they now have the four problems. We also have problem J opened already, so there are a lot of things to do, and it's interesting to see that many teams have kind of different set of solved problems. And also a small comment from our analysts on the backstage that the team from University of Cambridge, Sushi Warriors, who mistakenly submitted problem B, they also have incorrect submission for problem L, and their solution is kind of incorrect. It misses one important part. So, but the interesting thing is that their code is almost correct. It would be kind of easy to convert, but they need to understand that their idea is like kind of wrong.
Yeah, and I was corrected that JetBrains team has different team members, so I only know people from Jump trading team, but still. So that probably would be better for them. That could be easier to win.
Yeah, and speaking about your coaching work, we had yesterday the costs for the next year NWERC from the Karlsruhe Institute of Technology on our stream. So, like, what do you think? Would you prefer stay in Delft for 1 more year or travel somewhere else? Or maybe do it in Leiden? We now have problem statements because it's time, so you can also take a look if you want to.
No, I'm really interested in having a competition abroad. Of course, the last time it was outside of the Netherlands was the online competition in Iceland, in Reykjavik, 2 years back. And I only started coaching after that, so I'm very interested in being able to see other places.
Yeah.
Since it has been in Delft now for the 3rd year in a row. So I'm very excited about what also goes on.
Will we see NWERC at Leiden University?
Well, we might, so the local Benelux round, the VAPC, will be in Leiden in a couple of years. And during the evaluation of the location, we have seen that it's probably big enough to organize an NWERC there. So I am trying to push it that we will have an NWERC there somewhere in the next 5 years or so.
Yeah, long time to wait, but hopefully we will get it, because 5 years, considering the fact that it's only 5 tries for each team at semi-finals, then probably the team set will be completely different by then. But anyways, maybe people who are now participating as your team will help you with coaching in 5 years. No, still not more than 4 problems solved. We see that the contest hall is filled with these pretty balloons with green and pink colors. Now it's much more colorful than in the beginning. it's a pity that I think that in the World Finals it's a great concept that each university has their own T-shirt with their own color, and the whole contest area is looking so like colorful and different, and you can easily identify teams. But yeah, at least we have multicolor balloons.
What a shame that it's all very blue, but still it's very recognizable to see. It's a lot of fun to be in the more communal spaces, so like the introduction speech and the after the scoring, the jury presentations. Be able to identify who does what. So of course you have the runners in the red and the organization in the dark blue. All the teams in light blue, which is, I think, a lot of fun to see.
I think also the jury has like orange also.
I quickly looked at sponsors teams, and Jump Trading solved 4 problems, but they have incorrect solution on problem E. That's solved by almost every team.
They also released the submission. They also have an information that there seems to be team from the Hasse-Plattner Institute. They're trying to solve problem Z, and they have just some slight mistake there. So probably they will successfully pass it soon and join the teams with 4 problems. And yeah, on the stream you just could see quickly the results of sponsor teams that are trying to catch on our contestants, but are not very good with it for now. And yeah, the top team now has 5 problems actually. We have already 2 teams with 5 problems. I think it's still not all the problems that are already opened in just half an hour.
Yeah, we have 7 open problems, so there are still 2 more problems to go.
That's crazy actually. All of those problems should be solvable by the top teams, obviously, and I think there are a couple of more problems that should be solvable by the top teams, but still interesting to see. We can clearly see like who likes what, who are more, I don't know, like dynamic programming guys and who are more implementation guys.
Yeah, well, I like that when you have a lot of problems to solve, you can choose freely. They all are quite not so difficult. You can solve them in some time, because when I participated in some training camps, some days there was so hard contests that in the middle of the contest there was maybe 2 or 3 open problems from 10, 11. Yeah, that like frustrates a lot. When you read all the problems, you look at them, you have no idea how to solve all of them.
It's like some crazy difficult Chinese contest at Petrozavadsk programming camp, and the only person who solved like 5 problems out of 13 is Gennady Korotkevich, and he's like, and all the rest are like 3 problems at max, and it's 5 hours past, and you're like, okay, nice contest.
Yeah. When you go on editorial to listen solutions, and still you can solve it, even after you know how.
Does your team have any like specific persons who dedicated to something like to math, for example, or to data structures?
Yeah, so of our 3 teammates, 2 of them are in both mathematics and computer science. And that means that they will mostly be focused probably on the more math-heavy or puzzle-heavy problems, whereas the implementations are usually left aside, or like later. Expect that they will mostly solve the harder puzzle or the math-heavy puzzles earlier.
There are some math tricky problems today, so we'll see how they crack them, be successful.
Do you guys want to discuss some problem? So I suggest to discuss problem E, because Jump Trading finally solved it from second try. And well, that is the second easiest problem today, I think.
At least according to our contestants.
Yeah. Well, problem A is solved by almost every team, and I believe it's really easy. And E, the second easiest problem, and it is already a bit interesting. So let's discuss it. I will describe. Oh, we can see statement on the screen. So what is the problem? We have some string, and we do the following process. We concatenate string with itself. So if we have, let's say, ABC, after that we will have ABC, ABC. And then we leave every second letter. We take the first one, then third one, then fifth one, and so on. So after that, length becomes the same as in the beginning. For example, if we had ABC, we will have ACB in the end of that. And what is the problem? We need to do that operation k times with the string. And we need to say how the string will look in the end.
And the tricky part is that k is up to 10.
Yeah, yeah, and we can't
you
just simulate the process because k is a really big number. It's up to 10 in 18 power. So what can we see? If length of string is even, then we will actually take every second letter in a string and then concatenate result with itself. For example, if we had A, B, C, D, result will be AC, AC. So it's every second letter of A, B, C, D, and the same again. And if string has odd length, then we will take some permutation of its letters. I believe that the best way to solve that problem is to look how result will choose for strings of different lengths. To start with string of length 1, which is quite straightforward, then 2, then 3, and write down, let's say, first several steps, how it will choose after first operation, after second, after third, and so on, maybe until it will cycle. And yeah, if you do that, you will notice that
for odd length is just a permutation.
Yeah,
which is just applied all those k types. So it's just a constant permutation. And if the length is odd, you just immediately see that writing it on a paper that is the same permutation. So you just need to find this permutation and apply it k times, which can be done either in some complicated ways.
Yeah, but actually that is quite easy permutation. You can just see that you do jumps. If you do one operation, you will do jumps with step 2. If you did 2 operations, that will be jumps with step 4. If you did k operations, that will be jumps with steps 2 in power of k, modulo n. So you can just calculate that number and get the result. But yeah, if length of string divides by some power of 2, first several operations, you will leave less and less letters from the initial string. For example, if you had, again, string A, B, C, D, after first operation it will be AC, AC, and after second operation it will be A, 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 A. So if n is divided by 2 in power of, let's say, m, then first m operations, you will leave less and less letters. To be more precise, after ith operation, you will leave every 2 in power of I letter. First, let's use 0 indexing, then it will be 0, then 2 in power of I, 2 multiplied by 2 in power of I, 3 multiplied by 2 in power of I, and so on. And after m operations, actually you will have some small string concatenated 2 in power of m times. And then after that, if you write several examples of how string changes, you will notice that that small part will change in the same way as just string of odd length. And then we already know how to solve the problem for n with odd length. And yeah, problem consists of two parts. Firstly, we should yeah, I think firstly we should solve it for even cases to solve.
Because you can reduce the even cases to to
and
odd
then
cases.
after we've got string of odd length, we solve it, and yeah, that's all. And yeah, we can see that almost, I believe, more than half of teams already solved the problem, and it's quite interesting. You can solve it watching at several examples, which is good. You don't have to, write a lot of formulas to prove everything. You can just see how it changes, and it's quite simple way how it changes, so you can just solve it as well, which is good also. Yeah. And yeah, why jump trading had the correct solution? Their solution crashed if n was power of 2 completely. So in the end we've got string of length 1, and some why for some reason they had some bug and it crashed their solution.
Power of 2, so you can reduce
Yeah.
1.
Yeah, you should remember about that case.
0 index.
yeah, you do. Also, there is a case when you have string of length 1 initially.
Yeah. You just basically need to think about those edge cases while implementing, because but it's actually cool that there are a lot of teams solving this problem. Because to be honest, I was thinking that a couple of other problems should be a little bit easier. Like we will discuss them later on in the stream. But I thought that like J or L are kind of more straightforward. But there are a lot of teams.
Yeah, maybe they just take more coding.
Maybe, don't know. I felt like not, but we'll see. Maybe we'll see the same amount of teams solving J and L as see what will be the next solved problem by the Leiden University. Yeah, I think that they're taking a bit of time, so maybe they are implementing something a bit more complicated like J or L. Trying to test it, also all the edge cases and stuff. I believe that they go pretty fast with first two problems, so they have a good penalty. So, don't want to distract you anymore from the cheering for your team and relaxing while they are working to prepare what you will tell them after this contest, how you liked it or not from them. So thank you for coming, and thank you for the insights on your preparation and your work.
Of course, thank you for hosting me.
Thank you.
Thank you. Yeah, we'll have a short break and we'll come back.
Yeah, I don't think it'll work like this.
And welcome back, everyone. There is now again only two of us.
Yeah. And let's quickly look at Scoreboard. We have 7 problems solved by the team in the first place, but there are even more open problems. They solved problem K, which is solved by only them. And also there is problem F, which is solved by several teams.
And problem H.
Yeah, but they solved H.
Yeah, actually this problem K is kind of reasonable that we see it. I think it's the next in terms of difficulty because the problems that everybody is solving. And now the challenge begins for the top teams because basically those B, C, G and I are the most challenging problems. With M, I believe that the top one team will get it with problem F sooner or later.
What will be the next problem, would you say?
To open it? I don't know. I think it really depends on the preferences of the teams. I think that if we have more math-focused teams, then maybe we will see either I or M, because they are something around math calculations. You need to think about some numbers, some formulas, and stuff like that. I'm not sure that we will see G soon, because I don't know.
Yeah, I would say that would be M, in my opinion. Well, I don't know problem I at all, so that might be I too. But I don't think that problems B, C or G will be solved soon. Then that's just my guess from what I have already seen.
Yeah, I agree for sure. And we see that like currently in the top, we see many teams that we are really familiar with. So we can see the Kindergarten Time Limit and Psychological Bird in the first 2 places right now, from the Northwestern Institute of Technology and Delft University of Technology. Those are the teams that consistently on the top each year. I think Kindergarten Time Limit also participated in last year NWERC. There are also a team from the University of Oxford, plays Scoreboard, who actually now has more problems than the University of Cambridge teams, which were the first ones to solve the first problem, the problem A, but now they're struggling to get the 6th or the 7th problem. And there are some other notable teams, like the teams from the Frederick Southern University and the University of Cambridge, so always mentioned them, but still we also see the team from the KTH on the 12th place, because we had them yesterday on our stream with their funny mascot picture of their friend. So we hope that you are now watching us and rooting for your team. They're doing pretty well. Let's wish them the best of luck. But actually, we can just mention that right now the top one team from the GCPC from Germany is in the first place, so the second place is the team from BAPC, the third place is the team from UK, and the fourth from the Nordic preliminaries. So we have a mix, a representative of each of the preliminaries are now sharing the top 4 places, which is pretty fun to watch. And the team Freezing Smile from the Chalmers University of Technology finally beat their fellow friends from the university, and they're now the top one team from Sweden. So we'll see how it goes. But there are a lot of teams that actually can reach the top pretty quickly. We see the team from Aalto University on 14th place with 4 problems. Those guys were the first ones during the Nordic preliminaries, so they have incorrect submission for L, so they will definitely, I believe they will have 6 or 7 for sure. And there are other very, very good teams there. But while we are waiting for some more interviews or more guests, we can actually discuss a bit more problems, I think. Let us hide the scoreboard so you can take a better picture of the contestants. Now you can see on the live stream that we now have much more teams with 3 balloons and more balloons, so our contest hall is becoming more and more colorful. So let us share with you the problem A, for example. It's the easiest one, the most straightforward one. So, Nikolai, do you want to explain the statement? Why I can do it?
Yeah, I think you can.
Yeah.
Describe previous one.
Yeah, let's just do it pretty quickly. This is very, very straightforward problem, which is definitely should be solvable by any team that is here with us today at NWERC. Basically, you are given some set of strings, which are some Dutch surnames. Actually, like if you look at the samples, there are some very funny surnames from the Witcher universe, and other funny stuff. So thanks our jury members for having those little jokes in the statements. Yeah, and basically what's need to be done in this statement is you need to read all the lines. They can have some apostrophe, some characters, and you need to sort this set of strings, but the sorting condition is that you compare only the part of a word that starts with the first capital letter. So it's kind of straightforward. You just need the strings, find the first capital letter, sort it.
Yeah, left on that part, and then I believe you can just use standard sorting order programming language. And yes, since n is only 1000, and strings are not so that should work.
Yeah, I believe this is the kind of problem that definitely should help us to have this golden rule of ICPC to work out, that like each team should solve at least one problem, but no teams should solve everything.
Yeah, but there is also one more rule, that there shouldn't be a problem solved by everyone.
Really? I thought that it should be the case.
Well, that is the hardest part, because if you add a really, really easy problem, well, it will be solved by everyone. It helps to satisfy all other rules.
But for now we have just several teams in our scoreboard to solve the problem A. I'm not sure that they even here now. Yeah. Maybe they are not here, that's why they haven't solved it yet. Let's see, maybe they will manage to do it. Also, a quick small notice is that actually if we look at our company teams, let me show it like this. Now we see that the first team from sponsors actually also has 7 problems.
Yeah,
like
and they solved problem F and didn't solve problem K. Opposite to kindergarten.
Yeah. I don't know. Do you know if the contestants can see the company's scoreboard? So they also can see, like if company team, which consists of like super experienced guys, if they open some problem, it also could be an indication for contestants like what they should solve now.
Well, I believe that there will be 2 parts of contestants. Top part will solve that 7, 8 problems that are already solved, and then they will try to solve one of 5 left problems, and it will be interesting to see which problems will be solved. And second part, that will continue solving these 8 problems that are already opened till the end, and well, they will just solve some part of it. So yeah, there are two parts of participants.
Yep, just got an update that actually one of the sponsors teams, they had some weird issues with problem H, but when we were chatting, they always overcame them and solved this problem. So skip this for now. And
the amount of times it takes to repeat should be.
yep, now to solve several problems. I know we can continue discussing some of them. The most easiest ones.
Yeah,
we
let's
can
do it.
proceed with problem
Just print out each line.
J. Should be the next one, right? Yeah, difficult.
Then we can get past it.
So, speaking about problem J, I don't know if you're familiar with that.
Yeah, I didn't read second half of it, so you have to
So
you have to
you know
describe
only
for me
the funny legend about the building and construction. So basically, if we skip all the interesting part of the statement, the problem is about some cranes that have different height, and we should
Should I do like 10 characters?
the jeeps
Do 2, 4,
in
6,
such a way that they wouldn't collide with each other. So
the amount of
mention
times it takes until it repeats will.
this way, yeah. If you have two jeeps, they are rotating, two cranes, they are rotating somehow, and if the length of a jeep of one is too much, it will intersect with the second one. So you have the points on a plane where they are located, and you have the height of all of them, and all of the heights are unique. That's kind of helpful. And basically you want to find the maximum possible length of a jeep of each of the cranes in such a way that they are not intersecting and the area is maximized, the total area that they are covering.
Alright. Is there any limit on length?
Yeah, it should be not larger than the height of the crane itself, because otherwise it would fall down.
Yeah. Well, I think we should start from the highest. It can have the maximum possible length because it won't intersect with anyone. It is the highest. After that, we will go to the second highest, and its length should be no more than distance to the first, and no more than its height.
But that's no good.
And that's all. There are only two limits. And then we can go to the second. And again, since n is no more than 500, you can iterate for every gram.
What if
all
n can be up to
that
10
are
to
higher,
5?
take distances, take minimum of them, take minimum with 8 gram. That's all.
Yeah.
Yeah, exactly.
We have to do 5 million times.
The square solution, because it's only 500, like for each crane, just yeah, you're correct. Just take the distance to the closest crane that has larger.
What if
Yeah.
n?
It really looks a bit easier to
The
describe
length of
than
the string is
problem
10,000, then we know
Yeah,
it's going to
yeah,
take.
for sure. It's easier to describe, and I thought that it would be solved faster than problem E. I know, for me it really looks like some of the top teams just read the problem E randomly in the start of a contest, kind of immediately understand what should be done there, solved it super quickly, and then everybody started focusing on it, because it's obviously that it should be easy and easy to implement.
Yeah, and
Problem is,
even
we can't keep dealing
solution
with exponential.
should be shorter in J.
We can't deal with it. Just that.
Yeah, I think so, especially if you implement it in some
So we need to figure out like,
normal
I
way,
think
like
this
just
is
think for a minute
roughly-
before you
Yeah,
start
yeah,
implementing it.
if you have function to calculate distance between 2 points,
This is like
Yeah,
you don't need anything
roughly
actually.
the formula is, right?
yeah,
Two
Can't be
cycles.
doing
yeah. As we don't need to calculate any the area itself, you just need to take distances. You actually and compare distances.
Yeah.
You can do everything
Imagine,
in
imagine
integers.
if you should calculate area.
Yeah, initially I thought that it should be done in this problem. After reading it, I
Yeah.
was like, oh no.
Well, I don't really like that type of problems where it's obvious what you should do, but it's so hard to code. Like if you need to calculate area. In real life, you would use some
Okay, so
library,
let's just think about this.
geometry.
The first one is 2, and the second
Write
one.
that on the contest. It's
Wait, hang on.
really hard and
The first.
struggling.
No, I think.
Yeah,
Do it
I
again.
totally agree.
So I can guess. I should go to
We actually, while we were speaking, the top 2 teams solved their 8th problem.
Yeah.
Now they solved all this set of the problems that we were expecting that somebody would solve. All of them, for
Well, I
sure.
believe
0, 2, 4.
I and M
Then it
will be solved
becomes
soon.
0,
And C and J. Sorry, C and J. Interesting.
8.
Yeah, would be interesting to see if anybody would
0, 8.
solve them successfully.
16. 1. No, think of it.
So do you have any statistics?
Look at this,
How
right?
many?
Look, imagine it's an infinite
many
string of our thing repeating, right? This is the pattern of indices.
To be
And
honest, I don't
what
know.
is the next level?
To be honest, I don't know, but I will figure out, and we will come back with this after a short break. And yeah,
Then
stay tuned.
This is what the indices of our infinite string, like 32 character, right? So how do we? What do you think about this, right? This is the pattern. We look at the indices. Obviously, it wraps around, so all of this is going to be mod n. These are the indices that goes in the pattern. So it's I. Yeah, so the indices I to the I times k. No, 2. Yeah, it's I times 2 to the power k. That's the indice for each individual.
Probeer ik maar eens en wat komt er zo niet in? Wacht, ik is wat trouwens. Oh, wacht even. Over maar is dat
And welcome back, everyone. We are now joined by a jury member who will be kind enough to tell us about the problem K very, very soon and how it should be solved. It's now, I believe, solved by 3 different teams. So, what do you think about the contest so far, overall?
So far, well, teams are very quick with the first half of the problems, that I would say. Yeah.
Did you expect that, or it was like a bit unexpected?
I expect them to be fast, but they're maybe faster than I expected. But this is nice. I'm glad that we have lots of strong teams this year in NWERC. I'm more curious about the difficult problems and how much they will get solved. It was expected that the first half will be quick anyways. But so far it's going well. And yeah, excited for the rest of the contest as well.
Yeah, for sure. And yeah, I think the problem K is one of the couple or maybe several problems related to graph theory. So it's always nice to have such problems where you can apply some of the theoretical knowledges and algorithms. So it's nice to see that our contestants know these algorithms indeed and manage to solve it. So yeah, maybe you can tell us a bit more about this problem, the statement actually, and the solution. I don't know if we should put statement on a stream. I'm not sure because it would be too huge of a picture. So maybe you can just explain it to us.
Yeah, unless you're setting up the slides at the moment, but I can start talking about them. So this problem is called Krautnote. I hope I pronounced this well enough. It's a typical Dutch snack that people seem to like here. I haven't tried it yet, but maybe we should try it out. So this is a graph theory problem, as you mentioned. It's about Carlin regularly going to practice competitive programming with her teammates at the campus. And she goes for that from her home to the campus. She walks, or I think in the story she actually bikes And we have a bicycle network modeled as an undirected weighted graph. And we want to go from vertex 1 to vertex 5. So the problem is the following. Caroline wants to stack Krautnote to bring her, with them to the training. And she wants to do so in the shortest possible way. And the catch is that the stores not always have Krautnote available. And from past experience, she knows the probability that the stores do have them available. And she can also check which stores have them available or not. So we are given for every vertex some, either they have a store or not. Here, for example, the vertices 3, this vertex 2, and the vertex 5 are stores that have Krautnote. And we have some probabilities attached to them that they are available now or not. So in this particular context, stores 3 and 2 have them available, while 5 are out of stock, even though they do sell them. And the problem is the following. Given the probabilities, what is the shortest path, the shortest expected path from vertex 1 to vertex 5, such that we can stock Krautnote on the way? Right, so in this case, the shortest path is this one. We take 4 plus 5 plus 2, because store 3 indeed has them in stock. And the first observation is we are talking about the expected value. So if all the probabilities are less than 1, then the expected shortest path is infinite, because there is a possible situation that none of the stores have Krautnote in stock, and then the shortest path to stock them just does not exist. So we can assume that one of the probabilities is equal to 1, and we always have at least one store with Krautnote. And then the problem is indeed just calculating the expected value. So what we can do to solve this is, for each vertex, we can calculate the shortest path from vertex 1 to this vertex. In this case, to vertex 3, just this path. And we can do the same from the target vertex. We do this for every vertex, and then we have some distance for every vertex here. And what is now the expected shortest distance from vertex 1 to vertex 5, including one of the marked vertices? So we can use the linearity of expectation. And we sort all the probabilities, P1 to Pk. So let's assume that they are sorted. And then we just, well, the observation here is that if, sorry, so let's sort the distances. And the observation is the following, that if the shortest distance vertex has Krautnote in stock, we don't really need to walk to any other store. So we consider the probability for the first vertex that they have Krautnote in stock. Take this distance, and then we sum this up with the condition that they do not have Krautnote in stock. And then we can recursively solve it the expected value that this is the case. So consider vertices 2 to Vk. And this is the linearity of expectation that we can do this in recursion. And this solves, this gives them the expected value. One of these probabilities is equal to 1, and this will make sure that the result in the end is not infinity.
So the D at V is the distance, the shortest distance if we use the shop located in the vertex V, right?
Exactly. So the distance of vertex 3 here is the distance between 1 and 3, and the shortest distance between 3 and 5.
So you can basically like run some kind of Dijkstra algorithm 2 times.
Exactly, yeah.
Final distances. Okay.
That's exactly right.
Okay, yeah. I was also thinking that maybe we can calculate this if we, for example, but it's maybe more on the implementation. If we, for example, write to some list all the vertices with some fixed d, with some fixed distance, right? And then just iterate over all possible shortest distances that we could have. Then what we need to sum up is like for each distance is the. I was thinking about like probability of not having cookies in all of the stores with such distance, which is just 1 minus each of the probabilities. So you can calculate this and multiply it by this distance, and then just sum everything up. But maybe it's just the same in different format. Or I'm wrong.
It might be similar. So what you're saying is that you consider all the possible distances for every store.
Yeah.
I
just want to iterate over distances rather than over source, but
right.
it's just
I think it's pretty much the same.
Yeah. Okay.
Yeah.
We actually now have the truth note on our stream.
Oh, great.
You can take them if you want.
Yeah, I would love to try them out.
That's the best part of being in jury, while contestants need to crack the crude note and problem during the competition, you can just crack them in real life. Yeah, thank you. Yeah, it's a pretty nice problem. You need to think about the probability theory and also about the graphs. So yeah, I'm definitely expecting more teams to solve it. At least while we were speaking, there are already 4 teams, so it's just +1 successful submission while we were speaking. But I think that we will see more. Interestingly enough, there is even a team from the University of Cambridge who solved problem M, but they didn't solve problem L and problem K as well.
Okay, interesting. It might be that they just liked problem M.
Yeah, sure. Maybe there are some math guys in a team.
Right. I think I would. I have expected K to be solved more or less at this time as well.
So your expectation is that the next problem would be M. And what do you think about the other problems? What do you expect? Like problem I? What would be the next one?
The next one. So can I see a scoreboard somewhere?
Sorry, we can actually put it on a stream. It would be easier also for you to see it. Oh, now it's there, and we need to show contestants, right?
So one thing that I think was interesting was that J was solved quite late. I consider it actually the easiest problem of the problem set, but the illustration was a bit intimidating maybe, given that it's a geometry problem.
Yeah, for sure. We also just discussed it before you joined us.
Right.
And discussed the solution. While I was reading it, initially I was thinking that you will need to also calculate the area.
Right,
discovered by cranes. When you see such picture, you're like, oh no, I want to do it. And that's why people were solving problem E. I was also thinking that L is more straightforward than E, because like there is also always a problem on binary search, on a contest. So
So I think I and B are probably the 2 hardest problems together with G. So I think the next ones to be solved are definitely M and C.
Oh, okay, interesting. Because we were thinking like between us with like Nikolai and our analytics team that maybe I would be the next one to be solved, not C, but we'll see.
It's also possible because C can be quite tricky to implement if you don't do it well enough. And in fact, we actually got a solution, accepted submission to C now.
Yeah, so you were right. Okay, yeah. I was just thinking that like while you are in the first half of the contest, you sometimes don't want to gamble your time on some implementation when you can forget about some edge case or whatever, and it's like not so straightforward to test. While some of the other problems, you just if you solve them on paper, you can definitely implement them. Just go and do it.
Right. Yeah.
But interesting to see.
I definitely expect a lot of wrong answers also for C coming soon.
Actually, it's the sponsors teams who solve it. We're now seeing all the teams, so none of the contestants solve it.
That's interesting.
Let me update it this way. Yeah, now it's exactly the same, but without this single team.
All right.
Interesting to see. But as far as I understand it, the contestants also can see the company's results. So, or not?
That's a good question. I don't know.
We thought that yes, because if yes, then it's definitely a hint for contestants where to go next.
Definitely.
Because interestingly enough, the jump trading team still haven't solved the problem K, which we just described. I would expect those guys to crack it, but we'll see.
Looking forward to it. I'm sure they will manage.
Yeah, sure. So, is there anything else you wanted to share with us on the preparations? Is it your first time being on the jury?
So it's my first time as an NWERC jury. I was GCPC jury 2 times before that. And, I guess NWERC is a little bit more exciting than GCPC as well, as a jury member.
So we also could expect you next year for the NWERC in Germany to be a part of jury?
I would like to. If I can come up with an interesting problem, then I will submit it and be glad to help. So,
Cool. Yeah. So thank you for coming and for sharing the problem K with us. We will not bother you anymore with questions and let you go to continue working and closely monitoring the contest. So thank you for this explanation.
Yeah, thank you as well, and have a nice continuation of the stream.
Thank you. We will have a short break.
J and L I think it might be just DP ball. So for every... hang on. So, like, keep the hash rate, right? And what do we keep track of? So we've got to make... Basically, we've got to make sure that the sum is greater than... Is it greater than or equal to half? The sum has to be greater than or equal to. So the sum has to be greater than half, majority, but it also has to be less than that number plus the minimum number. No superfluous parties, right? So in this example, we what is it, 6, 3, so it's 12, so they have to total at least 7, right? We couldn't have 1, 2, and 6, because they total 8, and we could get rid of 1. So they total 9, we could get rid of 1, we left with 8. So that's a superfluous one. So 2 and 6 is valid, we can't have it with 1. So basically, if we pick a number 1, we need to figure out how many combinations there are that equal the total 6, because we've got 1 so far, so they have to be greater than 6, but less than 8, because 8 would be too much. Right? Very good.
And hello everyone, once again. Now it's Alex's turn to take some rest, relax, and I will talk with a new jury member, and we will discuss problem M, right?
Yep, that's right.
Okay, but let's start with watching on the scoreboard. What's new do we see? There are 6 teams who solved 8 problems, and there is 1 team who solved problem M already, which is University of Cambridge. Yeah, and talking about problems that will be solved. My guess was that teams will solve problem M, the first of 5 left problems, which is correct. So yeah, let's discuss problem M.
Yeah, I also guessed that M would be among the first solved of the most difficult problems, but I must say it came a bit quicker than I originally thought. So, let's say I thought maybe 2 hours after we started the contest. But yeah, I'm glad it was solved. University of Cambridge solved it a bit quicker, than all the other solvable or easy problems. So that's nice. We can get to the problem now. Do you think?
Yeah. You can describe the statement or start.
Yeah, so the problem is about this cat, Medea, and he jumped in between mice, and we'd like to do some interesting calculations with it. And maybe I can do it over here on the whiteboard, blackboard. So the mice, they sit on the vertices of a convex polygon. So we say like this. So we have mice at the vertices, and then Medea, the cat, jumps somewhere inside at a random place, uniformly random place. So let's just say that she jumps all the way over here. So then Medea is interested in calculating how many triples of mice can encircle her. So, for example, if we take this, and this mice, they form this triangle, and she lies inside this triangle, so they encircle her. However, if we take these 3 mice, she's not inside, so she's not encircled. So we're interested in finding the expected number of encirclements, considering that the location is a random variable, uniform random variable inside this convex polygon. And so it's an interesting problem. How can we approach it? Of course, this is a continuous random variable, which is kind of intimidating because you probably don't want to start integrating over two-dimensional area or whatever. So yeah, originally I was hoping that this is too intimidating for people to approach. But the thing is, we don't have to be dealing with any sort of continuous random variables. What we can do is work with indicator random variables. So we can say that the number of triangles, let's say the overall answer, let's call it x, is equal to the sum of other indicators, let's call them S. And what's the indicator? The indicator S, I, J, K. It's a random variable, and it's equal to either 1 or 0, depending if the cat is inside or if it's outside. So, yeah, so this is the answer to our problem. We would like to have the expected value of x. And just like the previous problem that we discussed, linearity of expectation applies over here. So we can write it as the sum of the expectations of the original variables. Okay, so we can work with that. Now how can we find the expectation of such a variable?
A straightforward solution is to iterate.
Yeah, so this is a sum for 3 variables. We can have a naive solution that's just 3 for loops and just iterate over I don't know, all triples of points, and then find the expected value for this random variable over here. And the expected value for this random variable is actually kind of straightforward. So for example, if we take this triangle, what's the expectation of it? Well, it's 1 and 0. So it means that the expectation is just the probability of having 1, which is just its area divided by the overall area of the polygon. So we can say that it is something like the sum of the area of the triangle IJK divided by the overall area of the whole polygon. Now, this is an n-cubed solution. And yeah, we can proceed with that if n is small up to like, I don't know, maybe 500 or something. But n in this problem is up to 10 to the power of 5. So we need something much bigger. It's not going to work. So what we will be doing is we're going to be inspecting this sum. So instead of working with the sum of all triples, we can try to imagine what are we doing. We're just iterating over all triangles. And we can say that, OK, instead of iterating over all triples at once, let's say that we iterate over all segments. So we try this segment, and this segment, and this segment, and this segment. And then for each segment, we find all combinations of the third point. So we can maybe write it in a better way. So it's the sum with respect to all segments, and then the sum with respect to all third points, which is k. And over here, you can have some expression that kind of maps to this one over here. Now, the nice thing is that this expression over here, the sum with respect to k, it can be aggregated over this entire segment over here, and it can be pre-computed in ON overall. So if you pre-compute it, you can say that this thing over here ends up being found in O1. And so you end up with an ON squared solution. Which is better, but it's still not good enough. Yeah, so there you would need some algebraic trickery. So you would, if you just expand this expression that we're writing over here, this area divided by the overall area, it's going to end up being like a huge expression. And it's like maybe we don't have time to go through it over here. But you can apply the same trick again. So you can pre-compute a lot of sub-expressions in that expression. And you can do like kind of like 2 layers of pre-computation on top of each other. And you can actually solve the problem in linear time eventually. Now, how that exactly works, it's left as an exercise for the avid reader. But yes, that's the overall idea. Just discover that you can write it as a sum of indicators. And that makes the search space much easier. And then realize that, well, the expression if it ends up being just divisions of geometric areas. And then realize that you can actually reduce a sum from ON cubed to ON squared and then to ON. Yeah. And then that's it.
And how long is your final solution? How hard does it look?
I think I don't remember the exact number, but you can solve it in like 30 lines of code or so.
That's impressive.
Yeah, it's.
Yeah. When I was thinking about that problem, you know, I came to that solution when you fix 1 point and trying to calculate areas of all triangles with that point. Mm-hmm. And you have a double sum for that fixed point. And then I wrote the whole sum and I understood that, well, I can calculate it using some data structures, but that solution would take maybe 100 or 200 lines of code. So 30 lines is really, really small for such kind of problem. It looks very, it looks hard, but yeah, if you write all these formulas on paper, then it turns out to be quite easy to code.
Yeah, it is quite easy to code. You don't really need any, next level data structures for it or anything. Yeah. But now the thing is, it's interesting to talk about precision in this problem.
Yeah. What precision?
So this overall sum ends up having like a bunch of huge terms. And it is the case that just doing it straightforward with long is not going to work. Some sub-expressions, if you just do it naively, it will overflow 64-bit integers.
Numbers, right.
Yeah, so you would like to be careful with that. You'd like to use long floating points. Or you can use GCC extensions with 128-bit integers, and that will make your problems go away. Now, the original formulation, it was actually that the encirclements are not just triangles. They are arbitrary subpolygons. So in that case, even the ON cubed solution is not going to work, because it's going to end up, the naive version is going to end up being O2 to the power of n. And eventually, you can solve that thing, that variant, also in ON, but with way more mathematical trickery in between. So we thought that, well, maybe it's not an algebraic competition, so let's not do that.
Too hard for the contest. Yeah, well, and what if you use, let's say, double or long double calculations? Will it work?
Yes, long floating points would work currently. If you look at the limits for the problem, the limits for x and for the precision, they are set up in such a way that doubles would work. So, yeah. Now, another interesting development of the problem was that originally the solutions were meant to be modular. So that you would print the solution.
In that case, you don't have any problems with precision. But well, problem looks much more, much less natural when you got some random integer number, and well, yeah, it proves that you can solve the problem, but
yes, exactly.
It looks strange.
We didn't want this extra mental overhead of doing modular computations, and actually the jury split exactly in half over the decision whether we should do it modular or not.
As a contestant, I would prefer a problem with modular arithmetics, so that if I have correct solution, I will code it and it will work. Because if there are some floating point arithmetics, I can have a correct solution, but it doesn't pass due to some, not very accurate code. Actually, I believe that costed me quite many solved problems in my career. Yeah. And also I wanted to say that it's good to have such problem on a contest where you can solve it on paper and then write quite easy. Because, well, there are 3 participants in every team, and one of them is probably a mathematician, so they will have something to do. They will save some time for their team by solving it on paper, instead of, for example, writing easier in terms of understanding, maybe, but more long solution with some data structures. Yeah. And now we have 2 teams who solve problem M, which is great. And also 1 team solved problem B. And I believe we discuss it later. Maybe we can have a look at solutions of problem M and see what's going on there. Let me check. Not really sure how to do that. Yeah, it looks like what you described. Quite short solution with single for loop and some calculations in float 128.
A safe choice to go forward.
Yeah. Well,
and no data.
Do you think it's a good thing to use such type in your solution? Because it's as far as I know, it doesn't work in every C++ compiler. I'm not sure.
It's correct that this is specific to GCC as a compiler. However, you should know your tools.
That's completely.
Compilation commands are published way in advance. And pretty much this is kind of like
Yeah, that's
using
great
GCC's
advantage.
extensions
That's
is very
great
common.
advantage. Yeah, and I believe it works quite faster than, for example, big integers in Java.
Yes, so this compiles down to machine instructions,
Yeah.
and yeah, it's not
Well,
emulated.
obviously it's slower than long, for example, which is
Yes.
The most regular type, but still, yeah, it works really fast.
Then I guess if you're writing a linear solution, which where n is up to 10 to the power of 5, you don't really care much, do you?
Yeah, sure. All right, thank you.
And congratulations to the two teams solving M so far.
Well, congratulations for you. Yeah. And I think we will have some break for now, and we will return in a short time.
So it's X, Y, and H.
du skal, fordi der er en ting, jeg ikke har til. Expectation er uendelig. Fordi du skal til sandsynligheden for, at der ikke er nogen, der er nok med gang med hver den længste stik i tid. Bare fjerne det skal du ikke til.
And welcome back, everyone. It's two of us again, and now a bit of time without guests and complicated tutorials. So let's just relax for a bit and see how it goes with the current results, because there are actually a lot of things going on. We have a first successful solution for the problem B, which is one of the hardest problems actually of the whole contest. We know that jury even expected it to be solved after the problem C, so it's kind of unexpected.
Yeah, that's surprising.
We also have more successful solutions for problem M. Now it's 3 teams already. Some of them even haven't solved problem K yet. So I think after our editorials, we can speculate that it should be the opposite. They should start with problem K, but anyways, it's good for them to have this more complicated problem solved. And a bit of an update, I think we didn't speak much about our first team, our current first team, this top 1 team from the Karlsruhe Institute of Technology, our next year hosts. They actually one of the strongest teams we have here today. This team had 18th place in the last World Finals. They were pretty close to the bronze medals. They also were 18th, I suppose, at European Championship last year, and they were 3rd at the last year NWERC edition. So
yeah, that's impressive.
Yeah, those guys definitely know how to be in the top, and they have a great penalty because they were first to solve K, L, and B, which gives them a lot of opportunities.
Yeah. When you participate in World Finals, you are given some money for that.
For the first to solve. Everybody who is watching, if you qualify to the World Finals and you are first to solve some problem, there is a money prize, separate money prize for that.
Yeah, but probably you would earn more if you work instead of practicing and training for ICPC. But yeah,
we are not speak about this here, Nikolai.
Yeah, how many years did I spend on it? It's hard. It's hard to count.
No, anyways, the participation of ICPC is not only fun and knowing a lot of things and learning how to solve problems. It's about the community and also the skills that you learn. They're definitely helping you, even if not directly in your job. Maybe you're not implementing some complicated algorithms every day, but the way of thinking, the critical thinking, analyzing stuff and coming up with the corner cases, with like edge cases, debugging code under the very stressful conditions is anyway helping.
Yeah, but the most important skill that you can get while participating is to hold such streams. Yeah.
We actually have the first solution for problem C.
Not the first, already the second.
Already a second? Did I miss it? No, it was for the... Yeah, it's not refreshed on my screen, but we have... on the stream we already see both of them. 2 first solution for problem C. It's... I think like that our top 1 team was just 2 minutes late to get it correctly.
Well, the good thing that they solved it finally.
Yeah. And the other team that solved it is the University of Oxford, current first team, current champion from the UK, the team placeholder. Yeah, they actually now have better position than they are like rivals.
So there are only G and I.
Yeah, left to solve. Yeah.
And less than half of contests have passed. So there are plenty of time, and probably... What do you think? Will we see a team that solved everything?
Not sure, because actually we have only 2 problems that are not opened yet, but at the same time each team has at least 3 problems to implement. Yeah. Only 1 team 3 problems to implement, and we already discussed that problem M can have different underlying problems with doubles and stuff like that.
Yeah, it might... if you are lucky, you can solve it quite quickly. If you write everything on paper and then just code and you don't have any troubles with precision. But yeah, you can stuck. Firstly, you can implement much harder solution with some data structures, as I said, while we were discussing. And also you can have problems with precision, which is hard to fix because, that is not such kind of bug that you usually see. When you really have some mistake, you can fix it and everything will work. When working with floating point, you should, you should calculate precision that you have. You should think what type you should use. In that case, obviously you can use the float 128, which is biggest type that you have in C++, and it will help you to pass tests, but yeah, it might be hard.
Yeah, and so even having more than 2.5 hours, you still need to think about everything just to implement M, or to, like, for other teams, like the second team, the current second team from Delft University of Technology, they need to solve C, for example, which is also some brute force implementation, instruction
and
stuff.
it also might take completely different time to solve, depending on what you are trying to do.
And you notice that we are still discussing the problems that are already opened. So like there are still some difficulties and challenges in them. So don't know. I think there is a good chance that there will be some team that would solve everything, or at least solve everything except one problem, and will try to solve this last one, having some bugs, will be trying to submit it in the last minutes of a contest. I think that's for sure possible, because 2.5 hours, three strong guys.
Well,
clever.
I think I would say that probably every problem would be solved by at least some team.
Maybe. Also a good guess.
Yeah.
Considering the fact that we also have sponsored teams. Who can
Well,
some problems.
Jump Trading solved 10 problems. They didn't solve B, G, and I.
They solved I?
Didn't.
Okay.
So B, G, and I left for them.
Actually, also wanted to say that we have some fan of Sutherland University in our chat. We also cheering for them. I think they are pretty close to the top. They are now in 15th place. It's pretty close. They have Ash among the easier problems to solve to join the 8 teams club. So we'll see. And also I see some questions in the chat, the same questions that you, Nikolai, had about the who qualify where from this contest. So we know that for sure at least 3 teams would qualify from this NWERC 2024 directly to the ICPC World Finals, and at least 12 teams would qualify to the European Championship. And from this European Championship, where teams from all of the European sub-regions would compete, we will have at least 4 teams qualifying to the World Finals. The exact number of spots is not known yet, but we can definitely say that if you are in top 3 today, then you will be in the World Finals.
Yeah.
It's great to see that there is a bit of competition even between the same universities or between the same countries in our top. It's mixed, like several German teams, several UK teams, the universities that have more than 1 teams, also like both of those teams in the top, like Chalmers University of Technology, the guys that we had yesterday on our interview, the team Freezing Face is now on the 10th place, and their I believe their second team on 19th, so it's just one task, one problem, and still like more than 2.5 hours to go, so everything could shift for them.
Yeah, definitely. From what I see on Scoreboard, I believe that today's set of problems is quite good balanced. There is no, huge gap between some problems that you can. Sometimes it happens that everybody solve some set of problems and then nobody can solve anything else. And here we can see that teams slowly solve more and more problems, so there is no huge gap in problems, which is really good, I think.
Yeah, maybe except the problem like G.
Well, Well, I believe that we will see success.
Really?
Successful solutions on this problem.
For G? Okay, we'll see. That's interesting thing.
Yeah, I want to believe. Otherwise, it would be boring for teams on first places to spend the second half of contest without solving anything.
Yeah, that's also true. Actually, we now have only 2 teams that didn't solve anything. So you remember, like around an hour ago, I said that it was 3 teams. So
Yeah, and they didn't even submit anything, and they don't have. Oh, now they have index, so probably. I'm not sure.
Probably they're here.
Yeah,
they're not trying. No. Yep, most of the teams that are currently in the bottom of the scoreboard, they're trying to crack the problem E. That's actually, I'm not sure if this is the right approach. Even the problem J and L, I would switch. I think even that.
At least I would try to read different problems to try to solve them. Probably they are looking on scoreboard, they see that everybody else solved E, and they continue trying. But yeah, that is not a really right thing to do.
Yeah. I also always like when we have some interesting teams, like, okay, J and L are kind of straightforward, but we have a team from University of Bergen, and their name is some YouTube link, which is actually the recastly clip. Yes, I tried it, and
I thought you know it. You learned how.
No, I just like to be recalled. And the time I see it, I click on it. And they solved problem F, but they didn't solve the problem E and problem J and L. So also interesting to see. They can easily jump from 2 problems to like 5 by the end of the contest, because F is definitely should be more difficult than
not
E.
the easiest problem.
Yeah.
Well, sometimes not on that type of contest, obviously, but on some training contests, some teams like solving problems one after another. They solve A, then B, then C, and that looks funny. Because, they start not with easiest problems, and they confuse everybody who is trying to look on scoreboard.
Yeah, but I always believe you either don't care for results if you do so, or you are super strong and you do so.
And you will solve everything without any trouble, without additional penalty.
We can see now on our stream that there are teams with just enormous bunch of balloons already. It's always difficult to grab all of them after you exit the contest area.
Yeah, and sometimes they are filled with helium, I believe, so they are flying. And if you won't be careful, in the end of contest there are several balloons under the roof.
We can once more check scoreboard, because I think that let us switch to the test and scoreboard. Yeah, I saw that somebody asked in a chat about the scoreboard. There should be a link in the very top of the chat on YouTube. And it's pretty much the same right now, because just some teams are catching up, solving 7th or 8th problem, but as most of the solvable problems, basically teams are running out of solvable problems.
That's there won't be much of a change in the top of scoreboard anymore. The most interesting moment will be when someone would solve G and I, G or I.
Especially if it would be somebody unexpected from in the middle of the scoreboard who were implementing this for
if we look a bit lower, there is still a lot of problems to solve, and all teams are mixing. They solving problems, they are going up, and then they slowly going down.
Yep. Can scroll it.
Yeah, when I was participating in ICPC World Finals during COVID times, there was 1 year there was special rules that every team has 3 computers. Usually there are 3 team members but only 1 computer. But during COVID times they decided to change rules, and we had 3 computers, so we solved 3 problems in the same time, and it really changes tactics a lot, because usually one of set of members that you can have is one mathematician who just solve problems and doesn't write code at all. One person that only write, and he writes or she writes almost everything, and maybe one person who can do both well. But if you have 3 computers, it's much better if all team members can code something. And we had such team, so Scoreboard was quite a mess. You know, when you can simultaneously solve 3 problems, you submit them, you got +3 in the Scoreboard, you going up really fast.
Yeah, I remember the change. I didn't like it much because I think it kinda kills the idea of the teamwork.
Yeah. It changes a lot. And I don't really like it either. And it's great they didn't continue with that format.
Yeah, but obviously, like, probably
it can still work, but it is just different format, different Olympiad, different competition, not the ICPC format.
Yeah, like some marathon style or some optimization things.
Yeah, I like
huge
actually
project.
participating in some marathons when you see it for 24 hours solving the same problem, which is also different type of problem when you don't have correct solution, when you have to find some solution that will be as good as possible, but not the most optimum one. And sometimes it's even funnier to solve such problems.
Yeah, totally agree because
it feels like less of sport and more of fun.
Yeah, I think sometimes it could be really interesting because you need to come up with at least something, let's say, or solve some part of a problem. And as we know, on the ICPC style contest, you need to solve the problem at full. Like in comparison, for example, the IOI format where you have different subgroups with different tests and you can implement multiple solutions and like different levels of participants or different knowledge of different areas of algorithms can anyway give you some points. In ICPC, it's a bit more stricter.
Yeah, you either solve problem or not.
Yeah.
Nothing else.
We can, I think, quickly take a look at some other easy problem while we are chatting and waiting for more editorials from jury or for some other guests. I can share some insights and ideas about the problem L, which is also kind of straightforward. Basically, in this problem, you have some very huge bookshelf with a set of shelves, not more than like 10 to 5th degree of them. Each shelf has some capacity, how many books you can place in it, let's say X books, and also it has some height, so it's not more than 1 billion centimeters, let's say. And you also want to place some art pieces on those shelves, and you can put an art piece on a shelf if it has at least at most Y books. So the total capacity is X books, and some of them, if there are not more than Y, you can put there some art object. And your goal is to place M books that are given to you. You're given the set of books, the set of their heights. You need to put them in some of those shelves and put as many art objects as possible.
All right.
So I think that's the binary search problem in this contest. Basically, I think the first idea is that you probably would always put those books kind of greasily, starting from the largest ones. And the same with shelves. You would probably iterate, like filling shelves with books. You would always do it starting with the largest ones, basically. So that means that probably you would put art objects in the smallest shelves, right? So if you sort those shelves in the decreasing order of heights, then you can binary search for the amount of art objects you can place, And now, when you fixed the number of art objects you are placing, you simply can iterate and greedily fill the books, because now you know that capacity of each shelf is either X if you didn't pick it for the art object, or it's X minus Y.
Yeah, sorry, let me ask. So, art objects doesn't have height. They can be...
Yeah, I think so.
Okay.
Because like the legend is something that you maybe choose those art objects afterwards, so they don't have height. So you just... I think that that's the main thing why you can do this binary search, because you can always just greedily...
Yeah, but
take
every shelf
ones.
should contain at least one book.
Ah, really?
Or not? I'm not sure. What if we have
a
shelf without books?
I think that's also okay.
And what height will it have? One?
No, the shelves, they have predefined height. It's like, it's a bookshelf.
Ah, okay, all right.
You bought it from IKEA and put it in your room.
I thought you can choose heights as well.
No, so the set of height for each shelf is predefined, and the set of heights of books is also predefined.
Yeah.
So you always start with the largest ones and just fill them in, and the lowest shelves, you just use them to place art objects.
Yeah, that should work.
Something like that, yeah. And you always need to place all books. That's what you must do. You can skip a book, and yeah, it's maybe the case that it's not possible to fill it overall, but it's also like easy to check. You just run this binary search, and if you find any answer, then it's impossible.
Yeah, it's quite easy problem, but I believe it's harder than J.
Yeah, I think so.
And maybe harder than E, but I'm not sure here.
From my perspective, it's kind of similar. I would prefer to.
Yeah, they're
this,
different.
Maybe
in L, it's really easy if you met similar problems before with binary search over an answer. But if you didn't, that might be hard to solve.
Yeah, that's for sure. If you are not familiar with this idea overall, then it's definitely kind of complicated, and you can come up with these kind of greedy ideas, but they're not giving you the full solution.
I can perfectly remember that time when I firstly met problem with binary search over an answer. I was reading it, and all right, I can iterate over answer without binary search, just iterate and check, and so I will find an answer. I wrote it, obviously that gave me time limit exceeded, and I was thinking, what else can I do? How else can I find an answer? I iterated, I checked, what else? Yeah, so it's hard to come up with that solution by yourself if you didn't met it before,
Yeah. I would agree that you should either listen to some lecture or some editorial to know the idea.
Yeah, maybe someone, your friend or your coach told you that idea.
Or we on this stream.
Yeah.
We now have 2 teams with 10 problems. I don't remember. Did we have it before? The placeholder team also had 10 or 9. They definitely were on either second or the third place, so they have maybe +1 problem.
Yeah, I think they just solved something.
Yeah, probably it's M with 150 minutes, because we're now 153 minutes into the contest. Okay, yeah.
And
thanks for us in this chat.
Yeah, and so half of contest has passed.
Yeah, it's officially half of the contest, and our first team, they actually tried to solve problem M, and they didn't succeed. So basically, maybe it's something we will discuss. Oh, they're trying once more right now.
Yeah, they tried again.
Interesting to see. Let's follow this, and it's almost there.
Do you think that's...
Yes, they
they solved it. Let me check what they changed.
Interesting.
Yeah.
I would say that it's something either with floating points or with some edge cases. Maybe they just did the replace
so
double with long double.
Pavel tells us that they have correct solution, but precision issues. Yeah, they had precision issues.
Exactly. Yeah. So
they used long, and they got overflow, integer overflow.
So basically, they just replaced the types.
Yeah, that's how it works.
I think we soon may be ready with some editorial from the jury member. So we will be taking a very, very short break to prepare to present to you some of the problems, so stay tuned.
These books are bigger than the shelf.
These books are bigger than the shelf. If they're bigger than the shelf, then we either put it in a shelf above the ones we're doing, or is it possible? And that's a valid output, possible. Always putting shelves in their lowest possible position, right?
I just think you're going to get to the end and you're just going to have a bunch of art and you're not going to have enough shelves.
I mean, let's try it. But we always put it in the lowest possible shelf. We only put it higher if we have to. Okay, so we found the lower bound. Okay, so it pointer operand. So we -1 from it because we put a book on it. And if it's 0, we want to erase it because the shelf is full. So we get rid of the elements. We don't have anything with 0 in the map, right? That's our first case. I think we actually need 3 maps. Because we should probably prioritize. I think we need to prioritize putting things on a shelf that already has art in it. We divided our shelves into 2 spots: the regular, the free space, and the art space. Yeah. I think we should have 2 maps for the art space that hasn't been touched, art space that has.
And welcome back, everyone. We are now joined by another kind member of jury who joined us today to show a couple of more problems. But at first, let's discuss a bit how the contest is going. Did it go how you expected?
Well, I think everything goes smooth, but for sure people are solving problems very fast. Like, I think the best team is at 11 out of 13 now. It's like crazy. I don't know, I guess the team is very good, but I guess also the problems might be a little bit easier this year. Hard to say. I think we weren't expecting them to go this fast for sure.
But there are a lot of problems, like 13 is...
I think, yeah, last year we might have also had 13, but 13 is a little bit on the high end, yes. And so we actually were thinking if we should drop a problem, specifically actually one of the two hardest problems. But in hindsight, I'm very glad we didn't do that. It's good we have some more hard problems for teams to work on.
Yeah, I hope that they won't be able to crack all of them.
I don't know, it would be cool if this team solves all problems, but hopefully not before the last half hour of the contest or so. So yeah, we have like an hour and a half left where they should not solve everything and then it's going to be fine. I think the hard problems, there's some very fun stuff to do, and they take more time.
Yeah, for sure. And the top one team from Delft is now on 9 problems. Yeah, they haven't yet cracked C, but we will soon figure more.
This is actually a very interesting thing that to me C, which I will explain in a moment, is quite a bit easier than B. And I think the top 2 teams solve C now, but actually B was solved first. And I think B is very hard, but if you happen to see it by magic, then the implementation is not that hard, and you can do it. But I guess we will explain this at the end of the stream sometime.
Yeah.
Or later into the contest.
Tricky problem.
Yeah.
Okay.
No, as B, I didn't actually solve myself. I spent like 10 hours thinking about it. I didn't.
Crazy.
Yeah.
So maybe if some of those team members would like stop competing next year, you have great candidates for jury.
Yeah, we're always looking for new jury members, so everybody's welcome.
Great. Okay, so maybe we can move to the problems discussion. Let's start with the problem H. Let's say I remember that it's interactive problem, and it's also kind of tricky and funny problem. So
absolutely.
More on it.
Yeah. So also maybe I mentioned in the test session we had a multi-pass problem for the first time ever, and we did also make a multi-pass problem for the main contest, but yeah, we didn't use that because we wanted to test it. So apart from interactive problems, we now also have a multi-pass problem, set of things we can do. And so we have this hash collision problem, and there's a very long story, but the short of it is here on the slide. You're given a function from n to n, from the set of 1 to n to the set of 1 to n, where n is up to 200,000, and then you can ask 1,000 queries, where you ask f to the power c of r. So just you do f of f of f of f of f, and so on of r. And then we want to solve this equation that's written on the third point, that f to the power c of r is c. So we want to find, for example, that we start at 1, and we apply f 1,000 times, and then we should end at 1,000. So let's go to the blackboard and see some examples.
Yeah.
So this equation is the one to remember. I will quickly write it down for you.
The problem statement.
N is up to 10 to the 5. We want f to the power c of r to be equal to c. This is important. Okay. And so a kind of standard technique, I would say, in this setting is that we can have like number all these points 1, 2, 3, 4, 5, 6, 7. And so these are like our points, and then we map 1 to 2 when the f of 1 is 2. And then 2 maybe goes here, goes here, goes here. Something like this. So now every arrow, it goes from 3 to 5 when the f of 3 is 5. And now we can ask, what does it mean if we apply c times f of f, and then we end at c. So let's say we want to end at 7. Do we have different colors? Yes. Let's say we want to. Let's say we want to end at 7. So we say c is 7, and then we say if we apply f 7 times, we want to end here. So we need to find a number that if you apply f, you get here. So it's 5, then it's 3. But we see that we can kind of only walk 2 steps back from 7. So we have like f to the power 2 of 3 is 7, but we wanted to take 7 steps. But now we only have c is 2 here and c is 7 here. So it's not that solution to this equation. And so let's erase this one and make another attempt. So let's see, if we take f to be, if we want to end at 2, we want to take 2 steps back from 2. And so we can start at 7. So we take, this is r, is 7, and we take 1 step and 2 step, and then we have f squared of 7 is 2. So this would be a possible solution. So now we hopefully have an idea for the problem. We want to find a point r, no sorry, a point c, and then c points backwards, so that we end at c, if we apply c times. And now the question is how to do this, and one of the main observations is that if you have such a function like this is a graph, directed graph, on n points, and there's also n edges. And so this will always have at least one cycle, one directed cycle. And so in this graph, we have a cycle here. And so if we have a cycle, things become quite a bit easier. Because for example, if we take 6 now, let's say we take this to be our C, then we want to take, no wait, let me do another example. We take this 4, now we want to take 4 steps back. And in a cycle, we can always take infinitely many steps back. So we can go 1, 2, 3, 4 steps back. So we can say the f to the 4 of 2 is 4. And the nice thing is that, like here with the 7, we had an issue because we couldn't take so many steps backwards because the graph kind of starts here. But in a cycle, we can always walk backwards, so it doesn't really matter how large this number here is. We can just always go backward along the cycle. So now our task is like to find a cycle. By using these queries, I haven't even explained this earlier. So in the problem, we can ask these queries that, so this graph is like 100,000 nodes. And we need to solve this solution by doing at most 1,000 queries. And so what you could do is just you ask the f of 1, you ask the f of 2, and so on, to reconstruct the graph, and then you can just do this in linear time. But we only have 1,000 queries, and the graph is much larger than that. So we cannot actually reconstruct the entire graph. And so the queries we can ask are actually, you can ask for these values. So you can evaluate functions of this form. And so one thing we can do now, let me see, is that we just start at 1. And then we ask for, we can ask for the f of 1, and the f squared of 1, and the f cubed of 1, and maybe up to the f to the 10 of 1. Okay, let me just do the full thing. F to the 500 of 1. And so now we kind of know if you start walking from 1, the first 500 steps that you get. And then we can ask the f500 of 1, and the f1000 of 1, up to the f500 squared of 1. Actually, this should be slightly different. We should probably, instead of, okay, let's start here. So what we're kind of doing to find a cycle is we first do a very long linear walk, which may not contain a cycle yet. And then we take very big jumps. And the idea is that we find a collision. So it's like kind of a square root decomposition where we take big jumps. And these jumps go along a cycle at some point because 500 squared is larger than the input size of 200,000. So this will for sure loop at some point. And the question is where? So we can ask this, and then we can also ask actually the 500 numbers just before this. So instead of starting from the left, we do this, and then we ask maybe the 500 numbers here. And now we can always detect a cycle. Because one of these points here will collide with one of these points here. And then once we find a cycle, so we have like, let's see. We know that this point, if you take like some number big C of steps, maybe I just do A. You take A steps, you get back to the same point. So there's a cycle there. And so now what we can do is we can take like, if this point is C, then we start at C minus A, I think. I'm probably going to get the math slightly wrong here. But basically, we need to find C steps back from this. So we can basically, we know the length of this cycle. And so to find like some point in front of this point, we can also just walk forward with the negation of the cycle length. And so this gives you a solution that takes like roughly twice square root n queries, and n is 1,000. And so if you do twice 500, it's slightly tricky because you need like one extra query at the end. So you might need 1,001 queries, but you can instead use like 480 a team did. I think I got the wrong answer. But then 483 is like square root n, that works. And it gives you like a little bit of buffer to the 1,000 for the last few queries. But as you already hinted, so this is the solution that most teams are doing now. But as you already hinted, there's a trick problem. We don't need 1,000 queries. We only need 2 queries. Yes. Now, I prepared a lot of time thinking about this solution, so I have to actually think about the trick solution. Oh, God. It skips me. Do you remember it on the point, maybe?
Let's start with... we should start with querying like to jump n steps from 1.
Yeah. I remember. So if we start at 1, we can just make a very big jump of n steps and we get somewhere. And now we're going to say, OK, we want to go back from here. So this is some number c again. So we want to find a number that after c steps, you map there. So we can just say from 1, we go n minus c steps to some number r. And then if you go c steps from r, you go to c. And so actually, you can just solve the problem in 2 queries. You start at 1, take n. I mean, you can start at any number, but most people just start at 1. It's the natural choice. You take n steps, and then you go c steps back by going n minus c steps forward from 1. And you only need 2 queries. And so this problem, I think, was solved by a few teams relatively early in the contest. And they all used this approach. I know. Then there was maybe a bit of nothing. And then 80% of the teams in the last hour or 2 used the n square root n approach, including the Delft team and I think most other top teams. I don't know exactly, but the earliest few were this. Another solution you can do is a randomized approach. So basically what we're doing with the square root n, you can also think of like the birthday paradox. If you just take a whole lot of random numbers, the probability that 2 of them collide at the end of a cycle, have like are multiple of the cycle lengths away, is roughly square root n by the birthday paradox. And so that almost works, but the constraints are such that it doesn't really work. And actually in the jury, we also had a randomized solution, and we added really a lot of maximal test cases to kill this birthday paradox randomized solution. And there were like 2 or 3 teams that submitted this.
But it looks like with the randomized solution, you anyway need to come up with the idea about the cycle.
Yes.
So if you come up with it, you should be maybe able to switch to the like square root solution.
Yeah. And another funny thing is like we had some discussion in the jury whether we like this trick version with only 2 queries. So I think the problem is, I mean, another variant we discussed that was also very early on is that instead of this equaling to c, you want it to equal to r. And so now you actually really need to find a cycle of length c that if you start at r, you end at r. And I think this problem, you cannot do the Q trick, but the square root n trick still works. But we decided that we want this cube inside here. So teams can solve it with like 5 lines of code. Others use like 30 lines, 20 lines to do the square root thing. So yeah, I think it's actually a very cute problem.
Yeah, that's crazy. I don't know what is more genius for contestants to come up with a tricky solution with this one.
So it seems like some of the, I don't have the scoreboard in the top of my head, but I know, I think quite a bunch of the high teams, they might actually just think, oh, finding a cycle is easy, I've done this before, you just do the square root trick, and then you stop thinking because you have a solution, and then, at least that's from my own experience, as soon as you have a solution, you just go for it and you stop thinking, right? But if you think like 5 minutes more, maybe you could have the cute solution.
Yeah.
Yes.
Yeah, that's nice. Nice problem. Like great to have a chance for maybe like a less experienced teams to just think for a bit more and just come up with a nice fancy solution and also crack this problem. And the challenge for the top teams to spend extra time and then still be in top. Yeah, that's cool. Thank you. We can actually we can get you back here and discuss the next problem. Let's say we can. If our viewers are not super tired, I hope not, we have more interesting problems to discuss. We can actually also discuss the problem C, right?
Yes.
It's a also tricky problem, which on the paper looks like easy, but it's not so easy. So yeah, tell us.
So what's the current scoreboard situation of C? How many teams in the top?
Yeah, let's double check this. We have, I think...
quite a bit more.
Yeah, on the top, like 5-6 teams in the top.
So I think when we started this, it was only 2 teams. So it's getting more popular now. I was worried sometimes you have the scoreboard bias where because B was solved first, people would try that, but it seems C is picking up now because it really is the easier problem.
Yeah, nobody actually solved B apart from the first ones, and some teams looks like they even prefer C to M, like the team.
I think that's reasonable. I
I
think that makes sense. So C, it looks very intimidating. Geometry is always like, Also problem J, it took a while to pick up steam, I guess, right?
Just because of a picture.
Yeah, exactly. And C, C is Manhattan distance is much more friendly than circles, of course, right? So hopefully it doesn't scare as much, but it hasn't been solved that much anyway. So yeah, we have the slide here.
Yep.
You're given this Manhattan grid with 5 points in them, and basically you want to construct a road network. So that's the red lines, such that from any point, any of these 2 points out of the 5, you can travel with them the shortest distance possible along these roads. So for example, between C and F in the bottom right, the Manhattan distance between them is 5, and indeed you can walk with them with distance 5 via this red line. And so we need to construct a road network that has minimal total length, but still allows all the optimal travel paths between these 5 points. So let's move to the blackboard again. Can you keep the slide here? I want to copy paste the figure onto the board.
Yep.
So we have I'm just going to draw the optimal solution for now. And then we have some point here, and we have some point there, and we have some point there and there.
It also partially looks like if we have less than 5 points, that it will be immediately much more easy to...
Yeah, I think with less than 5 is where it starts to be interesting. We consider doing 6 to make it more annoying, but then I think 5 is kind of the right trade-off where it's annoying but doable. 6 would be meh.
According to Scoreboard, 5 is already annoying enough.
Yeah. So we have so we have these points in the grid, and we don't know yet this optimal drawing that I did, right? There's just an infinite grid. But we can make a few simplifying observations. And basically the idea is you could do a lot of case bashing, and we have some ideas for brute force approaches, but all of them are really ugly. But we actually have also a very nice solution. And so the main insight in the solution is that, for example, this point on the left is the only point, it's the leftmost point. And so from here, we might say, okay, we want to go to this point via this optimal path, or we want to go to the bottom right via some path like this, something like this, right? Any kind of Manhattan distance between these 2 points could work. But really the critical insight is, if your point is more to the left than all other points, we can always just go right. We can, this red dash line, we could always replace it by this red dash line. So this blue, it's we're not losing any potential optimality by going right here. And so what we can do from this point on the left is we go all the way to the right till we hit this vertical line, right? We hit the next leftmost point. And similarly, we can, from the top, we can draw this line. Oops. From the right, we can draw this line. From the bottom, we can draw this line. And so now a few things can happen. Suppose this point wasn't here, but we had another point here. Then after we map this, so basically what we do, we draw this line, and then this point we replace by this point. And we, our answer, we memorize that we added length 5 here, we memorize the length 4 here. And so we kind of add some constant to our answer, and then replace this point to here, and so on. So let me draw that. I'm going to be okay here. Yeah. So we get, again, this rectangle, and we get a point here, point here, point here, point here. I missed one. Oh yeah, and one here. So let's do this again. Okay, great. And so after doing this, if you have 2 points at the same place, you deduplicate them. And then we can actually repeat. In this example, we get this rectangle, but I don't, if you there can be cases where you, for example, I think if the initial points are like this kind of W shape, if you do this compression, this goes here and this goes there, and then you get this triangle shape. And then you can do the compression again, this goes there and this goes there, and you get this period shape. Just right? So maybe I put the blue lines again. We compress this, and then we compress this, and then we just have a point. And so we can kind of repeatedly apply this transformation where you compress all the outermost points that are unique in their minimal x, y, or or maximal xy coordinate. And so sometimes you just end at a point and you already solve the problem. But sometimes you don't, and there's actually only very few cases that remain. And so you just kind of write a while loop, like as long as this compression step removes points, apply it. And once you're done, you have one of a few cases. So let's analyze those few cases. And so a very interesting point about these cases is like the minimum x coordinate, there's always at least 2 points of minimal x coordinate, and 2 points on the right, 2 points on the top, and 2 points on the bottom. So we like start with something like 2 points on the left, and we have 2 points on the right. And now, like you could say we have 2 points on the top and 2 points on the bottom, but this would be 8 points, and we only have 5 of them. So actually, most of these kind of situations you can come up with don't happen, and I'm just gonna draw like, so this is one of them with like a box and 1 extra on the edge. Then we have a box. I mean, you can also just have 4 points. That's kind of the easy case. But okay, let's do more here. We can have a box with 3 corners, and then 1 corner is kind of chopped off like this. And then one last case is a box with 4 corners and 1 additional point somewhere in the middle. And so really we only have like 5 cases to handle, but they're all a box. And actually you can think of each of these 5 cases. In all of these, it's very clear that we need the entire boundary. And here you can also convince yourself that this piece might not be optimal, but then you could also do this. But actually it's the same. And the optimal solution is just doing the full box. So like with 4 points, clearly just the box. With 5 points and 1 additional point, this is also an optimal solution. Here it's also already an optimal solution. Here it's not, because this point obviously needs to be connected. And now basically the insight is that you can either just draw this line or draw this line. And of course you just draw the shorter. So you take the minimum of the height and the width and you add that. So we also solve this. And so after this reduction, there's really only very few cases. And actually all the cases have the same answer, apart from this one if statement where you detect if there's a point in the middle, add the minimum of the width and the height. And so even though the problem looks very intimidating, once you do this reduction, it kind of comes together quite easily. I think one of these 2 cases somehow is much less obvious and easy to miss. So I don't remember which of the 2, but we added one of them to the samples too. Maybe we didn't, maybe we didn't. We were considering this at least. But I think you should just find all the cases yourself.
Yeah, that's actually interesting. It's cool because it was easier than I thought. Like when you know the solution, it's kind of you just really need to notice that you can iterate over this in the start, and then it's just easy cases.
Yeah. So I mean, other things you could do, since there are so few points, right? You could, for example, draw like this kind of this. I'm looking at the original picture now. You could kind of draw this like subset of the entire grid, right? And then you can imagine all kind of brute force approaches that only work on this subset, or like try all these edges. If you're really lazy, you could even do a like 2 to the power 40 solution that just turns all of them on and off one by one.
Yeah,
that's too slow.
That was that was what we were thinking about. Yeah.
Yeah. I mean, you can be a bit more clever on the boundary. I think you can get it down to 2 to the 24, but your code is going to be super messy compared to just the actual solution, right?
Yeah. Totally.
So I'm actually not quite sure if teams are doing the solution, but I think from the few I saw before, they do. They do exactly this step with a while loop and to shrink, and then a few cases. Yeah.
Yeah, we will definitely take a look at that and see what are the actual approaches. I think while we were speaking, it's kind of the same. It's still maybe +1 successful solution for C. Yeah, now it's 7. So
cool.
And somebody tried I. Unity from Cambridge. They didn't solve C, but they tried I.
I'm curious. I think both G and I are very hard. G is just a lot of work. Even if you have the idea, it's a lot of work. And I also, it's like a lot of math. It's kind of like a project Euler problem. A lot of number theory, and you need to just work your way through it and not make mistakes. I made 1 or 2 mistakes on my first 2 attempts. It takes time to get it right. Yeah.
Yeah. At the same time, I would say that I is more pretty, I would say, in terms of the ideas you get from the start.
Yeah.
So you immediately get some ideas which you can start working on and just trying to find some projects. And for G, you're like reading it and like, what?
I don't know. I think for G also you can have the right ideas, but even then, putting everything together is just very annoying and ugly in some ways. Yeah.
Yeah, for sure. Let's see if anybody would be able to crack any of them.
Yeah, we'll see.
We also can take a look at the company's team, but no, they haven't solved both of them, G, I, and they haven't solved B yet as well. Yeah. So, thank you for the tutorial. It was very clear and easy, actually, when we know the solutions. Now, it feels like, come on, our strong participants should definitely be able to do it.
Yeah,
so
but I think both C and H are solved. Actually, C is not solved by all of the top 10, right?
Yes, yes.
Eventually, I do expect that to happen.
Yeah, maybe in like coming hour or so, after they finished with the 10 previous problems, actually 9, I think. Yeah. So, thanks once more. Thanks again for coming here.
Yes.
And looking forward to have you for more tutorials next NWERCs or maybe even today. So let's see how it goes. And thanks everybody for joining. We will come back in a minute.
Dot end is past the iterator to outside. So begin is the first element, end is like end plus that means that basically, if I try to dereference shelves dot end, I get an out of bound. So that's just how I know that it hasn't found anything. Oh, it should be fun. It's not size. Oh, so that should be S dot size minus B, probably. Hang on. B is the number of art shelves I'm filling fully. Y is actually B. We want to minimize B, so B should be in max. B should be the min of B and M. R should be M minus 1. Else L should be M plus 1. See how S on size minus B. I know. That's what I could see when it was janky. That one works now. That one is free.
Third one should be impossible.
Right. I don't know if I redid that. That one does show impossible. And what's there? That should be free as well. It seems to work. Should we go for it?
There's L, right?
Yes. L is in library. Sure idea.
If we want to look back at B.
Yes. D and I think which ones did we actually do? We've done A, J, L. So there's D and F and K. But yeah, that's D. D is
Wait, K is also.
I don't know, going by the leaderboard, K is the next most commonly done one. But let's look at D. It is.
Okay. I think this party is very small. You have 2 seconds, I don't think I want to move. But it's only 60 parties, so there should be. We're allowed 60 to the power of 60 is all of the combinations. No. No. Oh yeah, 60 to the power of 60. Which is the few. But we can. I don't think we can look at combinations. What if 4 people? If we have it all, let's say we have 4, 5. Probably one. I'm still thinking of the counting, so we
My intuition would say it's probably needs to be ordered. Probably don't need to count it. It's probably something coin change like. You don't really count coin change.
Say that you take 5.
Yes.
8 is 5.
So the difference between 5 and 8 is 3. So you could binary search the 3 and you know that everything between the starting point and the point you found.
And then you just do the number of them to the power of...
So it will be...
Oh, because the combinations don't matter. Because it's the same regardless. Like 3, 4, 5 is the same as 5 or 3. With parties.
No, but in this case, for example, if you binary search for the difference, you would get the position of the lowest value you can pick, and
with that one, so then you go like 5, 3, 4.
Well, it means that in this example, if you...
Yeah. Do it with like 10. Where is it? 10. 10, 9, 7, 6, 5, 3, 2, 1. And this one. So that total is
what if we order 1, 2, we know that there's an upper bound and a lower bound, right? We know the lower bound is 4, 6, 5, half round, half plus 1. Yeah, the lower bound is half, right? What's the upper bound? The upper bound is what is the minimum
smallest parcel.
Smallest parcel, whatever. And we just consider the first party first, we know what the upper and lower bound is. What is, we think of them as n separate problems, and we just point change these It's similar to, it's like basically just dynamic programs starting at each point, there's a separate cache for each starting value. I don't, what's its place? Oh, it's 60. We've got loads of time. So we start a new cache for every lower bound. We know, we start at one point, we know the lower bound, we know the upper bound. We just cache it and do like dynamic program. Because that's the awkward part with the DP. We need to have a definitive start and end. But if we have a fresh upper and lower bound at each iteration,
so what are you doing? You get rid of the biggest or the smallest one? You get rid of the biggest one. So if you're doing like 10, if you're doing 10 to 1, and you do this one, you go like, oh, so it's 10, 5.
yeah, you just started the first one.
And then you cut off 10, you do the second.
Yeah. You never,
so basically
when I'm here, like if I'm considering 2, I never have to consider 1. So I don't have to worry about there being as long as I stay in the range. Oh, in fact, I could do a breakfast search. Yeah, I can start at 1 and then just do a breakfast search against all of them. That's ON squared. But the number of things I have could grow exponentially. But I know I'm never going to add greater than the range, so I think that's possibly fine. But what if there will be 1? I got 61, so my breakfast search would be 1. Now my breakfast search would grow to 2 to the... It would never grow more than 2 to the 30 though. What's 2 to the 30? Yes.
And hello everyone, again, we are here, we are looking at Scoreboard and waiting who will solve G or I.
Yeah, exactly. It's half more hour to go before the freeze time, before we will not be able anymore to see the actual results and the scoreboard will be freezed. So the last chance for us to see if anybody would come up with I on Gs in the next half an hour. There are actually several submissions from the team Unity from the University of Cambridge, which is now the second team from the UK and the seventh team overall. So maybe they will solve it eventually.
Yeah, well, at least they have something.
Yeah, like 1.5 hour before the end of the contest, it's definitely good to have some implementation if it's relatively close to the correct solution, or you just need to be finalized, because as we already know from jury, this is the problem that requires a lot of attention to details and stuff to work on.
Yeah. We have one team that solved 11 problems. Oh, and we have submission problem G from Segfold Go Burr.
Oh, that's actually very interesting because it's one of the top teams.
One of the hardest problems.
Yeah,
or even hardest
problems.
Yeah,
I think it's wrong answer, unfortunately. And they also have a wrong answer for problem C at the same time, so they're now working on both of them. I think we checked their code for problem C, and as we just discussed, the solution for C, they may be doing the brute force algorithm, or at least something with a pretty complex implementation, so we didn't even get the full idea of it. But it's definitely not the it doesn't look like this easy, or let's say straightforward approach that we now know, so it may be also difficult to debug.
Yeah, so I'm looking at solution of problem G, And well,
do you know the solution, or are you just trying to understand it from their code?
I don't exactly know the solution. I know how it should look like, approximately. Well, at least they have something. They have a depth first search, which is needed to find components.
Connectivity components?
Yeah, not connectivity. When you have cycles and components, how is it called? Double connectivity, maybe?
Oh, okay, it's because like directed graph, you mean?
No. In ordinary graph,
yeah,
when component is set of vertices such that there are at least two paths from between every pair.
Okay, yeah, then maybe double connectivity.
Yeah, I believe it's called that way.
Oh, that's
so anyway, they have something. They passed some quite big amount of tests, but then they get wrong answer.
Yeah, we now have a lot of teams with 8 problems actually. So with 10 or 9, it's pretty difficult to get this amount of problems because you need to either solve C or M, which are one of the most difficult problems of the contest. But there are a lot of teams who solve the 8 problems. Most of those 8 problems we already discussed. But there are also a bunch of teams who solved, for example, C, but haven't solved H.
So I'm looking at the test that they failed. I'm not sure if we can discuss it, but that is the test.
Okay, so you're just saying that it's kind of trivial.
Yeah, it's really really small test, so that kind of corner case.
Yeah, so maybe they just have some stupid bug, or for just for corner case. So it's not clear yet if their solution is completely correct or not. But that's a good sign.
Yeah, that's good sign. They passed quite many tests and they failed on some really really small corner case. So probably, at least they can try to write stress test.
Yeah,
and try to find tests. And since they have such small test on which their solution fails, so they can do that. And
I would just say that it's not really pretty to implement a stupid solution for this problem, to run a stress test.
Well,
I wouldn't like to do it.
I wouldn't either, but it can be done. You just store a complete state of your your field, and it works slow. You can solve it for fields of area at most 10, I'd say, but you can try. And since they have such a small test on which their solution doesn't work, they can find that test using stress test. So we will wait.
Yeah, that's very interesting that for both of our hardest problems there are submissions, and both of them may be correct with some errors, so it's very interesting to see. You can, by the way, check the I maybe of the Cambridge University if you have time, and in the meantime, while you're checking, I will just briefly check in on the Leiden University team, the coach of this team we had previously on our stream, and this team is doing pretty well now. They have 7 problems. Like if you remember, they had only 2 when we had their coach with us, and they had a rough start. After 2 problems, they had a bit of delay before cracking others, but now it's 7 problems and they're catching up with the top team, so it's nice to see.
Yeah, that's great.
I think it's also cool that on the one side, we may say that there are a bunch of kind of easy problems or problems that should be solvable by the strong teams this year, meaning that all of the teams are strong this year because we simply has less teams. But at the same time, I think it's super nice when you have a lot of problems and you are solving them, and you have great emotions having like 7 or 8 problems, because like if it's 10 in total and you solve only 4 or 5 in the end, because only 5 were like easy and others are difficult, it doesn't feel so great as if you like solve 8 or 9 and everybody has an opportunity, everybody on the team I mean has an opportunity to implement something, to pass
that's
something.
great. And I checked solution on problem I. Team made 2 submissions and they doesn't look much different. They failed on the same tests, and they barely pass any tests at all.
Okay, so maybe their
approach
isn't correct.
It doesn't mean they are far from solving, but yeah, at least they have some bugs that changes answer a lot. So yeah, there is only one test that they passed.
Okay, probably the simple.
Exactly, simple.
Okay. Yeah, and the top company team also has 11 problems, the same as the top students team. So it would be interesting also to watch this race to be the first to solve one of the hardest problems. And the second team from companies has 8, so this is also a very good number.
Yeah, and company team on the first place has worse penalty time than students team on the first place.
That's cool. That's cool.
Yeah.
Yeah, I think in the meantime, while we was anyways discussing what is happening and discussing around problems, and not much actually happening right now. We see only a few submissions. Everybody's thinking and like going through this last hour. So maybe we have one more for... No, it's not G. So I suppose we can discuss for a bit the problems D and F, for example.
Yeah, let's do.
Put it here. We have a pretty interesting problem D.
Yeah, let me describe that problem. So, if we simplify the statement, there is some story about coalitions and
Dutch Parliament.
Dutch Parliament, yeah. We had some stories here almost a year ago, I believe. Yeah, so there are several numbers, no more than 60. And what we want to do, we want to find number of sets of these numbers such that their sum is strictly more than half of total sum. And we cannot remove any number from the set so that sum remains strictly more than half. So that is called strict majority and no superfluous parties. So we cannot remove anyone so that it will remain strict majority, and it should be strict majority. Yeah, and we need to calculate number of such sets. At first, when I was solving that problem, I've seen 16, and I thought maybe we can do some meet in the middle exponential solutions, but then I thought more. I realized that it does look like an knapsack problem, which can be solved in two ways, either with exponential iteration over all sets or with dynamic programming. And here we have small numbers. All numbers are no more than 10,000, and their sum is no more than 600 of thousands. So yeah, we should do dynamic programming here. But a bit tricky, in a bit tricky way. Because we should not only calculate number of sets which have strict majority, but also which doesn't have superfluous parties, so that we cannot remove anything from the set so that it will remain strict majority. We should calculate number of sets on border between not majority and majority. Yeah. How we can do that? I don't know how to
But yeah, you can just do the default dynamic programming.
Yeah.
The knapsack problem where the...
Yeah, you can. But if you look at the result, you will know total sum of numbers in the set that you take, but you won't know if there was something that you can remove so that it will remain strict majority. What we should do, we should add parties one by one, and after we added new party, we should calculate number of interesting sets with that party. And also we should be sure, we need to be sure that we cannot remove anything from set. We can do that if we sort all numbers in decreasing order. Then, if we add current number to the set, sum of set it was less than half and became more than half. And also we know that everything what was before is not less than the current number. That means, overall, that we have set with sum more than half, and we cannot remove anything from that set so that it will remain more than half. Because all numbers are not less than current, and current moved sum from less than half to more than half. That is the whole solution. And yeah, it's a bit trickier than regular knapsack problem. When I was solving it yesterday, I forgot about sorting, and I told solution to Alex. Yeah.
Yes.
Yeah.
And you told me that you don't need sorting.
Yeah.
And I believe you.
I thought I didn't need it. Yeah, and today we realized that actually we need to sort.
Yeah. So basically, for the strong team, and even like for the teams in the middle, it was very, very solvable problem, because overall it's kind of straightforward default knapsack problem. You just need to think about a couple of more details. One of them is how to get answer, which is a general question for any dynamic problem, and it's kind of obvious that you just sum up the amount of ways to get a certain sums on the border, as you said. And yeah, there's another one about sorting. Is also it may be the reason why somebody could catch some bug, but it's also kind of on the surface, because you just thinking that, okay, this condition of having the majority, what should I do that my dynamic programming always supports this condition? Any set always has this condition. So yeah, this overall it should be very, very much solvable by our teams. And actually,
just noticed.
Yeah, just wanted to say that while we were discussing the problem D, we had the first successful submission and solution for the problem I, actually, and surprisingly...
It came not from the team that was trying to solve it.
Yeah, it was another team, the kindergarten time limit, the team that was consistently in the very, very top of our scoreboard, and they managed to do one more first to solve.
Yeah, and now they are leading by 2 problems.
And they are the only team to solve problems B and I.
Yeah. Well, if we are not considering sponsors teams.
Yeah. I mean, among the participants. Yeah.
Yeah, that's great.
That's huge. Yeah, having 1 hour and 50 minutes more to go. I think it's, considering the fact that they are the first one to solve problems K, L, I, and B.
Yeah.
And they have only 1 incorrect try for F and 1 for M. I think it's almost impossible to beat them by penalty.
Yeah. And by amount of problems too.
This is another topic. I don't know. Like, actually, we saw that the solution for like Delft University, they actually may have a solution for G.
Yeah, they may have it, but you should remember that kindergarten time limit, that is not correct that they just started solving G. I'm sure they are solving it for 2 hours already.
Yeah, you're right, because like before they submitted the problem I, like more than 100 minutes passed, so like almost 2 hours took them to...
Yeah, and they have 3 team members. One of them was solving and writing I, one of them was solving C maybe, and the third one, they should be solving G.
Yeah.
For a long time.
That's crazy. And now all of our top 3 teams, even top 5, have 10 problems.
Yeah.
So like, I would say that considering the fact that we have more than an hour, you should have at least 11 to qualify to the World Finals. I would bet on that.
Yeah.
Or like be the very, very first one to have 10. So it would be extremely difficult. But to qualify for the European Championship, it may be still possible with 9. I suppose. I think that the the bottom team that will qualify would have 9. So there are still a bit of a challenge for any team to do it. I think the top teams with 8 still have time and still have the possibility, considering their penalty, to jump into the top. So yeah, we will definitely have some intrigue.
Yeah.
And more and more teams solving problem C, which is also interesting to see. I always like it when we have some amount of teams in the very top that solved it. Then some teams that are still in the top still has some first to solve things, but they didn't solve it. Then again, some other teams that solved it, so that means that it should be solvable by them, and they're probably right now are struggling to do it.
Yeah, but sometimes, there are different algorithms, different topics, and well, that might happen that even strong team is just not good at some concrete topic.
Yeah, for sure. Unfortunately, and on the one side, unfortunately, on the other side, if you want to be the best team, you should be ready for any kind of problems.
Yeah, that's right.
Well,
you can you can believe that you won't meet that topic that you know bad, but yeah, if you are going on world finals, you should learn everything.
Yeah, for sure. And we have a pretty various type of problems today.
Yeah.
I think we had dynamic problems, graph problems,
Well,
geometry.
I think we have lack of geometry problems actually. There wasn't any geometry algorithms. There was geometry problems with mouse and cat, mice.
And also with cranes, where you
yeah,
use
but
to calculate distances.
Yeah. So you should be able to calculate area and distance between points, area of triangle, and nothing else.
Yeah, but I think it's okay. I think last year at NWERC the most difficult problem was on geometry, so it's actually nice to change the type of a hardest problem. It would be too boring if each year you just need to come to the contest, implement geometry for 1.5 hour.
Yeah, like on our semifinals, we have cactus problem almost every year.
Yeah. Nothing is happening again after this
we can discuss
submission.
problem F.
Yeah, we can briefly take a look at problem F to almost finish the whole problem set, leaving only the most difficult problems, which we maybe wouldn't discuss at all. I don't know. Let's see how it goes. But problem F is definitely something we can talk about. It's kind of funny problem because it has this pretty picture of the World Finals director Bill Poucher, with his nice hat, I suppose, and he's pouring the champagne into this great champagne fountain, and the problem is exactly about it.
Well, not exactly. There are no glasses. There are some bowls, I'd say.
Yeah, but still, we are trying to emulate this process. So basically, you have a very huge champagne fountain. It's initially empty. It has 3 multiplied by 10 and 5th degree levels, and you have the same amount of quarries. In each quarry, you either try to pour some amount of champagne into specific level, or you want to check how much champagne there are on a specific level. And the thing is that this whole system, it works like a fountain, as you can see on the pictures. If you pour more champagne that some level can contain, then the champagne overflows and pours into the next level, but only to the next level that has the largest capacity, right? Yeah, because capacity and width is
larger capacity.
Yeah. There's strictly larger capacity, and if the lowest layer overfills, then it's just poured on the floor.
Yeah, which is really unfortunate to use such champagne.
Yep. So basically, that's the problem. it may look like some data structure thing or something like that, but the trick I think is to understand that if you look at this fontaine structure as on tree, then things become different and much easier. You can say that
yeah, we just should find the next level for every level. So we should find where champagne will go if it starts overflowing from some level.
Yep. So basically, we can say that like, just find the parent level, let's say, for each of the levels.
And if we do that, it's easy to prove that we will have set of rooted trees, because every time we will go further and further down, so we won't have any cycles, obviously, and such structure will form several rooted trees. Yeah, so basically what we need to do, we should find nearest not completely filled level and try to fill it. We have some amount of champagne, and if we will find nearest not completely filled level, well, it will pour. Then we either fill that level and go further, or our champagne will over. Since every level can be filled only once, and if we will have some data structure to find closest level in the fast time, it will work in linear time multiplied by time that we need to find that nearest level.
Yep, yeah, exactly. So basically what we want to do is to find some way to effectively find the closest unfilled parent.
Yeah.
And this sounds like some data structure like the disjoint set union or something like that.
There are actually a lot of approaches for that quite educational problem. One of ways is to, use some really heavy data structures like, help me, what are these?
Heavy light decompositions.
Yeah, heavy light decompositions.
Yeah, because basically, like from some point of view, you just have in each vertex, you want to look when it's queried to add some champagne. You want to look at the path to the root, and you want to find the first place on this path, which when the sum is not equal to the maximum sum that it could be there. So you need to have this heavy light structure with segment trees, and
or we can, for example, use binary gems, some binary search approaches, a lot of different. But the most easiest way is to use disjoint set union. When we fill some vertex, some node, we will connect it with their parent. So initially we will start with a disjoint set of all nodes, and when we fill node of the tree, we will connect this node with its parent. And then, in order to find closest not filled parent, we need to just look at the component and find highest node in that component, and that could be done using join set union. We have two requests. We add edge, so we join two sets, or we want to find root of some component.
Yeah, and I think it also would be kind of straightforward to implement, because you just need to do the default implementation of the joint set union just with this P of V equals to get parent of P of V.
I really like the joint set union. That is probably the shortest algorithm on graphs and shortest data structure. You need only two functions, and both have length maybe 3 or 4 lines of code, and I really like it, and it works really fast actually.
And here you are even using only one of those functions, so it's even shorter.
Yeah.
So basically, yeah, this problem looks like. I believe that most of our participants, starting from like middle of a scoreboard and up to the top, they should easily understand that they can have a tree and do something, and then maybe the initial thought is that it's something complicated on a tree, and that's why they postpone this problem. As soon as a lot of teams started working on it, they maybe just realized that, oh, it's actually just 10 lines of code, and that's easy. That's why there is a bit of delay when it started to be solved, but right now it's like, I don't know, it's one of the most popular problems. There are even more people who solve this one than problem K, so it's exactly like graph things. Both of them are some kind of default graph things, so yeah.
Yeah. All right. We have incorrect submission from jump trading on problem on problem G.
Oh, that's also interesting. And we are very, very close to the freezing time. Only 3 minutes to go, and we will no longer be able to.
But in these 3 minutes, I can try to look at submission of jump trading. Because I'm really interested in what problems they have. So they passed quite a lot of tests. Let me have a look at some tests. Well, they failed at some really big tests, so I have no idea what's wrong. And they do mistakes in both directions. Sometimes they print impossible instead of possible, sometimes otherwise. Yeah.
Okay. Yeah, that's unfortunate, but we will hope that they will be maybe able to do it during the freeze time.
Oh yeah, they have 1 more hour.
Yeah. For now, we will have, I think, a short break before coming back with more content, so stay tuned. And we will now pause for a couple of minutes. And now we are truly back. Here we are joined by Nadine, who are now our director of the whole organization here for, I believe, third year in a row, right?
Yeah,
Here
that's
in
right.
Delft.
Yeah.
So how does it feel this year?
It feels bittersweet because it's going very well. However, it will also be my last year. And I am trying to enjoy every minute of it, but honestly, I am going to miss it a lot. So that's kind of how I feel, bittersweet. Yeah.
Oh, well, but maybe it will come back to Delft once again in some years?
Yeah, well, the thing is, I also am graduated now, so I'm also leaving Delft for now. Maybe not for good, you never know. But I'm at least leaving the CIPC, the committee that's organizing this contest. I already gave up my chair role 2 years ago, and we had 2 great chairs in between now. So I'm very, I truly believe that the team is doing great and will do great in the future. So I'm really happy that I can leave it all behind in good hands. Yeah.
Yeah, that's sad, but good to hear. And I believe you will be the welcomed guest here or at any other NWERC at any locations each year.
Yeah, I have had great responses to like the last few years how we organized it, made great friendships. So I do think indeed it will not be the last time that I will attend one of the contests. So probably still see a lot of people. So that's really nice.
Yeah, the ICPC community is great.
Yeah, as we discussed, community is really a great part of participating.
Yeah, it's so special. Like, I'm already involved with organizing programming contests now for 6-7 years or something, and with like NWERC then for the last 3 years. With all the people that I've got to know, they're all great people. The community is really nice. I was lucky enough to also visit the World Finals in Bangladesh, in Egypt, in Kazakhstan. And it's so nice to see everyone. It truly is a special community. Like you see friendships, like when you talk with people that are new there or already like quite tenured. Like some people have friendships of over 30 years. It's incredible to see.
Yeah, and you meet a lot of new friends, new colleagues. Sometimes you don't expect, and you see some person that you've seen on, for example, World Final.
Yeah, definitely. Yeah, it truly is an amazing experience to have been part of this for the last few years. Like from the volunteers to indeed like the friendships to the sponsors that we've had, the contestants themselves. Yeah, it's really nice to see.
I'm starting to be too emotional. Let's quickly switch to some more positive things. Like, for example, what was the difference this year? Because this year I think the venue is different, and very much is different. We have less team, and like last 2 years, especially I think last year it was maybe a bit easier because the year before it was kind of the same locations and everything, and this year there were definitely some new challenges. So I don't know what was the most challenging part this year.
Let me interrupt a bit. Last year, I remember we had a huge TV in front of us with a stream, and we can perfectly see what is going on. And this year we have that small monitor, and Alex couldn't see anything on it.
I'm trying.
Yeah, indeed. We have been organizing it at another location the last 2 years. And it was a really nice location. It was the Ala. We had a lot of space, bigger screens indeed. But unfortunately, that wasn't possible this year because we didn't expect to host it for another year. Normally, NWERC is given to the same host for 2 consecutive years, and then it's switched to another host, probably most of the time also another country. But unfortunately, there wasn't capacity to take over this year, so we stepped up to do it another year. But that did mean that we host a light version, or how I prefer to say it, a lit version with the E in parentheses. So there are quite some differences. And to respond to the question about like, was it more difficult this year? Actually, it was kind of easier because like it's a smaller location, so you have a better overview. You don't have to walk that many stairs. Definitely great. Definitely gonna have less muscle ache, so that's nice. And we've been hosting programming contest in this building over like, I don't know, as long as this building exists. So it actually was quite easy.
Yeah,
and
that's
well,
great.
I'm gonna knock on the table because I don't want anything to go wrong still.
Yeah.
We have still less than 15 minutes, to go.
And then closing ceremony.
Yeah, and then closing ceremony. We have some nice prizes again this year. So that's also very fun.
Yeah, it would be very interesting to see what would be the first 3 teams will be qualifying for the World Finals. Like, we can already see that there are 2 teams from the same university in top 3 right now, from the Karlsruhe Institute of Technology.
Yeah.
Our next year hosts. So yeah, it would be fun to watch. And actually the Delft University team is now, they also tried problem B after the freezing time, so we don't know yet if it's passed or not. But they're now working on 3 problems simultaneously, which can lead them to either win, like it's either win it all or lose it all.
Yeah, it is.
Yeah.
It is very, nerve-wracking, at least for me, because of course I'm a tiny bit biased. But it would also be really fun to see the Karlsruhe teams win, especially because they are hosting it next year. But it would also be amazing if one of our own teams would make it to the World Finals. But we shall see, and otherwise they will probably have a second chance at the Europe Championship.
Yeah, tell me more about that system. So 3 teams will be qualified to World Finals from that contest, and several teams will go to European Championship.
Yeah, if I'm not wrong, I thought it would maybe be 4.
4.
I think, but I'm unsure now. I always need to have my slides
yeah, and
with me.
My question was: are there any? Will there be any teams qualified from European Championship to World Finals?
Yeah.
Okay.
There will.
Okay.
Maybe that's the one that has 4 slots. Yeah.
And like at least 12 from here to European Championship, and at least 4 from the European to the World Finals.
Exactly.
Something like that.
Yeah, something like that. We had it in the opening ceremony. So for the people watching the stream, watch back the opening ceremony, and then you can see it at the slides. But yeah, it's a new system. We hosted the Europe Championship this year for the first time in Prague. It was a very successful edition. Unfortunately, I couldn't attend myself, but Verwoerd, our deputy director, was there, and he truly enjoyed it, so that was really nice. And this year, or like next calendar year, it will be in Porto, in Portugal. So really nice location. Really looking forward to it.
I wish I visited it when World Finals was there.
Yeah.
But I didn't.
No, I've heard great stories about that too. I also didn't get the chance to visit it back then. But
maybe this year you should try to visit it on the European Championship.
Yeah, I'm planning to. So hopefully it will be from the 28th to the 1st of March, or at least in the weekends of the 1st of March. So it will be really interesting to see how everything goes there. Yeah.
Yeah, for sure. And as you said, it would be super cool if the team from either Delft or overall like from BAPC would qualify this year, because I think that we have several years in a row when the team from BAPC did qualify to the World Finals.
Yeah.
Like we had teams from UK, from
Exactly.
Nordic region, from GCPC, but not from BAPC. So just for the sake of like, I don't know, changing university names representing the region.
Exactly, yeah. It would be really nice to have more faces from the BAPC again at the World Finals. Not that I'm biased or anything, but as you say, for like kind of the distribution of faces that you see from the Northwestern region, it would be nice. Yeah. And I hope, because like at the last World Finals, we didn't do that great in our region. So I really hope that this year we truly have some talented teams that will hopefully also end up at a really high position at the World Finals. But of course, being at the World Finals is already a big accomplishment. Not to downplay that, but yeah, it's always more fun to...
Yeah, you always want it more and more than you have.
I think that's kind of like a human pitfall, right?
Yeah, let's hope for this year, because like last year the results, there weren't any medals, but the results were still good, like 18th, 20th place, 35th place, so it was super close, like one more problem or a little bit less penalty time on some early stage problems, and it would be at least bronze medals, so yeah, we'll see how it goes. Hopefully those teams are still participating and they improved their skills this year. At least looking at the kindergarten time limit, we can say that they are definitely working on it.
Yeah, they are doing great.
Yeah. Amazing to see. Yeah, that's also a fun thing. Like when you are involved for multiple years, you can truly see the teams grow in their expertise. It's really nice to see also the different strategies that every team has. Yeah, it's really cool to see.
Yeah. And as they change their position from competitors to coaches, to organizers, or to jury members. Yeah.
To people who stream, who is doing live stream. Why you always forget about us?
The amazing team we have backstage here with us.
Yeah, and while we are talking, I wanted to highlight that Jump Trading team submitted all the problems. We don't know results because Scoreboard is frozen. Well, actually, I do know, but I won't tell you.
Don't tell anybody.
Yeah.
No spoilers.
Yeah. We'll see.
That's also a fun component of like the contest, to have like the company teams competing. They're truly very competitive. I sometimes get emails before like the contest and they're asking like, oh, who will the other company teams be? Because then we can estimate if they're good or not and how much we should train. It's really fun to see.
Yeah,
that's crazy. But anyways, if you're a company team, I think the main thing is to have fun and relax.
Exactly.
You already did it in the past. Now just...
Alex, would you like to participate in such competition as a member of a sponsor team?
I'm better in talking for 5 hours. Like, let's be honest. I didn't do this stuff for like at least 5 years already. So
well, probably if I had a chance, I would try.
That would be cool. I mean, you can always first practice with the spectator contest.
Yeah.
And then maybe find a company team that you can join.
Yeah, you should find company
that
sponsor the
first step. Yeah. But there are enough.
Or there is another way. You can tell your HRs to sponsor NWERC.
Yeah, if there are any companies watching on the live stream and you are interested in joining the contest next year in Germany, then you can always let us know. We're always searching for new sponsors, new faces.
Yeah.
A little bit of a small ads there.
Yeah, that's absolutely not a problem here. We also had ads yesterday for some Teams merch, so it's fine.
Nice. Yeah, we also have, talking about like merch and goodies, we had a special edition of the duckies this year that you can also see here. I don't know if you can see it also on the live stream. Yeah, like we have the notebooks, but also the duckies.
Yeah, we can even show them.
It's a special edition. It was especially made for NWERC. JetBrains really went all the way this year, so we're very thankful because duckies are like an old tradition at this point. And if you could have a look in the jury room, you can also see all the duckies that were collected over the years. Some from contests, some personally collected. So it's really fun to see.
Yeah, I absolutely agree that I think the merch is great from companies. There are like super cool stands, so everybody who is watching and considering participating, make sure you participate next year. You will grab a bunch of t-shirts and socks and other funny things to do. And what is more important, you will have an opportunity to discuss different internships and potential to work.
Yeah, because next at this contest is for fun and to, well, challenge yourself. It's also a great opportunity to look for your future career, to talk with companies about indeed internships, trainings. They also have some boot camps hosted throughout the world. So it's really interesting. And we see that a lot of old contestants from ICPC contest end up at the sponsor companies at great positions. So next to having fun, it's also great for networking and your career goals if you might have them already. And otherwise, this is the place to start thinking about it too. Yeah.
Yeah, 100%. Yep. Well, we don't have much of activity right now in the scoreboard. It's frozen. Not many teams are trying anything. From interesting part that Hasa Platinum Institute seems to be okay team try to solve problem G, so it would be interesting to see if they succeeded or not. But yeah.
Yeah, and we can see that Sigfold submitted B for the second time.
Oh, yeah.
So probably their first attempt wasn't correct.
Yeah.
We can guess. Yeah, and also I wanted to add that participating in such competitions actually helps you really much to pass interviews when you are looking for a job, because there is that alga session in at least some big tech companies like Google, and you should solve some actually quite simple problem like on programming competitions.
Yeah, I think it's part of like most companies, their interview process, at least at all the kind of tech or financial related companies that I see in the Netherlands. It's part of the process, and it indeed are not that challenging assignments.
Yeah. If you put that problems in competition, it would be solved by almost everyone, I think.
But it is good practice because like those assignments are sometimes also with time deadlines. Sometimes you get a day. Sometimes you have to solve them at the company itself. So that's a little bit more pressure.
Yeah.
So good practice here for that.
And there is a comment for your point from a chat from Lydia Perovska, who's saying that stop wasting commentators because they are significantly more needed than participants from companies teams. So we will have you in commentators. Sorry.
Well, yeah, I guess.
So yeah, I think we can maybe wrap it up. And thank you for coming.
Yeah, you're welcome.
This year, and I hope we will see you maybe next year or years after that, even if as a guest. Anyway, it would be fun to have you on stream and have your expert opinion on the different NWERCs organization.
Thank you so much.
Compare it with how the next year will be organized.
Yeah, I think they will do a great job. They already started with the preparations for next year. It's a great team, very kind, also very fun to be with. So I think it will be a great next edition next year. And thank you so much for having me on the stream. It's always a pleasure to be here. And yeah, I hope it's not the last time and that I will come back in the future to future contest as a guest.
Thank you.
Yeah, thank you. Good luck on the closing ceremony.
Yeah.
Thank you so much.
We'll be back in a minute.
Yes, and now we are truly back. So we just spoke with Nadine about the past participants who are still active members of a community, and here they are. We have now Pavel Mavrin with us, who is a former world champion of the ICPC.
You can be former world champion.
Yeah, sorry.
Don't do it like. Hello, everyone. I'm just old world champion.
But today you are with us as a representative of a JetBrains,
yes.
Let's say. So maybe you can tell us a bit about some activities that would be interesting for our participants, and maybe somebody who is watching and rooting for their teams, the students of universities of the NWERC.
We already had a talk yesterday. We discussed participants what we can get, what they can get from JetBrains. We have our internships program. We have our free licenses for educational and some other stuff, I don't know. So I'm not very familiar with all the stuff we have, but you can definitely look at it. So I'm working in the educational department, so I mainly work with educational programs of JetBrains. We have 2 educational programs, 2 bachelor programs, one in Cyprus, which I am working in, and another in Bremen, in Constructor University. So that's what I'm basically mainly working on. So also we have some other interesting programs, like right today. So we had a competition for high school students. It's called JetBrains Youth Challenge, and I was chief judge. So that's why I don't participate here as a JetBrains team, like I planned to.
Yeah.
Unfortunately, so that's why JetBrains team. But we actually solved some problem in parallel contest.
So what do you think about the contest? And how many problems do you have?
It's great. All problems look very interesting. I have no idea how to solve B, and please don't spoil it to me. I need to think more about it. I like problem G. I have some ideas how to solve it. That's probably wrong.
Yeah, participants are actively trying to solve problem B, actually.
Yas right now is working on problem C, I believe, and then that's it. So we're left with problems B, G, and E and I. We have no idea how to solve it. Yeah.
So you have only 3 problems left.
Yep.
Okay.
I assume Yas already solved problem C by now. I hope. Yeah, problem B looks very interesting, and I want to solve it by myself. So don't spoil it to me.
No. I think we don't know how to solve it either,
yeah.
At least in full. So yeah.
But all other problems I solved were very interesting. I love problem H. If I read today. Yeah.
Did you solve it with trig, or the solution with 2 queries?
Yes.
Ah, okay.
But I spent a lot of time finding these 2 queries. Yes.
Because actually half of teams, especially from the top, they have a complicated solution when they look for a cycle with a jumps. We have an editorial on
that's the first. Yeah. That was my first idea, but then after I started to implement it, I actually think, two queries is actually enough. Okay. Nice problem.
Yeah, that's the funny one.
Yeah. Why are you looking at me?
Because you are the much more experienced in competitions than me, so I thought you have some interesting questions for Pavel about he's also a coach, so he maybe has some tricks or advices for our teams, because I remember that last year and the year before, when I was asking many teams what do you do in preparations, how do you prepare for the contest, a lot of teams were we don't do nothing, we just solved a couple of contests and just came here for having fun. But this year I feel they are much more motivated or interested. I interviewed 3 teams, and all of them said that they have at least 1 training session per week. They work a lot on their teamwork, on communications, because they already have an experience that they have always some arguments during their actual contest. So it feels the level of participants is increasing. So
it's very nice to hear, actually. So in Neapolis University, I also see that people are much more interested nowadays in these competitions. So we had like 3 teams. And we have very small universities. University is small, but our groups are even smaller. So we have like 20 students per year. So it's a very small group, and we have 3 teams this year. Unfortunately, 1.5 of teams, let's say, didn't manage to get visas to the regional contest. So we have only 1 full team and 1 person from another team. But they all are very motivated, very interested. They solved like 2 contests per week, sometimes even 3 contests per week. So very motivated, they really want to be better in these competitions. Yes, and yes, I see it's a very good sign of what's happening to the community. Yeah.
Yeah, I think that's great, and it's so interesting to see because like the competition exists for so many years already, and you're thinking that like everybody who obviously there are new students, but it feels like it's just super cool that it's still growing and there are still more and more people.
Yeah, I feel like there was some less interest several years ago, at least maybe in our region. Less students were interested in really training a lot. That's what I felt.
Yes, in St. Petersburg universities, like in ATM or in St. Petersburg, I felt like the interest is going down, mainly because I believe there was more opportunities to get to internships without any competitive experience. So you just go to internships. And
instead of participating.
Yeah, so you have stuff to do more important and maybe more interesting than taking part in these competitions. But I see now that it's more. I don't know what's the reason why it's more interested people in these competitions. I actually feel more interest not only among the students but among the veterans as well. So if you look at the results of this Universal Cup this year, a lot of very top participants like doing it every week. So I don't remember something like this happened a few years ago.
Yeah, so you said about some advices, and I remembered an interesting story. When I was participating in my last semi-final, our coach was Gennady Korotkevich, and before the contest we asked him if he has any advice for us, and she said, just solve problems.
Yeah, that's good advice.
Yeah. When contest is already started or is going to start, there is nothing else you can do. You should just solve problems, forget about some, I don't know, less important things. Don't think how other teams will solve it. You just need to solve it yourself. Yeah, and that time we actually won semi-final, so that was a really good advice.
Being a coach again, so I know.
Sorry to interrupt you. Right now on the stream we have something interesting. It's the look into the I believe jury room, right? So we could indeed see all those tiny little ducks, and now just people trying to maybe read the solutions of the contestants in the last moments. So this is what is happening throughout the 5 hours while everybody's working. And yeah, here's this collection that Nadine told us about. So you see there are a lot of those different tiny ducks of any kind.
And not only ducks.
Yeah, and some other mascots. We should also put there this photo of this guy from yesterday. You haven't been there yesterday. We had some team that had their own mascot, and it's their friend who is now in Swedish military. Yeah, so thanks for our backstage team for giving us this secret view. So sorry guys to interrupt you. Please continue.
Yeah, that was end of story. Gennady gave us that simple but great advice, and we won competition.
I believe so. So this is the first year I'm actually coaching a team. So I was coach assistant a few times, but I wasn't really coaching something. But this year I actually coaching, and I think like during the competition, the main job of the coach is to make sure that everybody is everybody come to the contest. Everybody had a good meal before the contest.
Yeah.
Everybody sleep well before contest. That's what you do during the coach. You don't give advice during the contest. If you give advice, only to make sure everybody like the moral in the team is high enough. So that's what your job. You can give all the strategy advice during the trainings.
That's not time to teach.
Yes, right. I had a talk last year, if you remember. I had a talk about giving some advice about how to get better in programming competitions. This year I had another talk how I explained my failures during my competitive programming experience, and
yeah, but also like the teamwork and different strategies, they could probably work, but first of all you need to solve problems, and all the rest is the
that's true. And the trick is to solve as many problems as possible, but how to do it in given time. Yes, that's tricky.
I remember I believe the team that is now like solving as a company team with the jump tracing, when they were participating in a format like Belanogov, Smykalov's Bunny, right? They have this team formation. I remember we were sitting next to them during some workshops in Moscow, and they were so strict with different timings. That was crazy, because we were like just chatting and like, okay, let me explain you this task or read my code or whatever. And they were like, okay, I need 15 minutes. Then 15 minutes after that, they just stood up and like, okay, like time is up. And they were just giving up the computer right in the middle of writing code, and it felt like so, I don't know, professional and extreme. You're like, really?
That's how you become a world champions. Yes, that's exactly that. So yes, I remember when I was participating, we also have a lot of internal signals and internal like procedures how you do stuff. So we even for some again, you have some standard algorithms. We just learn how to implement them in the same way. So you don't, when you switch from one person to another person, you don't need to adjust. You just look at the code and like it's your own code. If you're really motivated to be a world champion, then you need to do all this, even small steps, just to solve the problems as quickly as possible.
We also had this case with a very, very similar code with my teammate Evgeny Belich. We were doing some like course on probability theory or machine learning, I don't remember, at university, and it was like some matrix thing, some formulas, but basically it was like kind of dynamic programming, and then you needed to apply some matrix. So like we solved it, like we were in different locations at the time, we submitted and stuff like that, and then our solutions failed automatic like cheating check, because the huge part of code was to like construct the answer from dynamic programming, and it was like almost identically the same, because code style is just the same how you just implement it, and before this is like 2 lines of transformations, and they were like completely different. But the stupid script comparing the like equalities, it was triggered, and we even go to the like director of our course to prove that we were not cheating, because otherwise we would have like a super strong penalty at exams. And our teacher was not believing us. He was like, I don't care, my script is working, so just go out. So we went to like to everybody, and we were like, come on, just look at our like the actual formulas is completely different solutions. So yeah. Yeah, we have how many? 20 more minutes to go. It's almost finished. There are a bunch of submissions for G and B.
Do you think the Reality Limit will have any chance not to win the competition?
No, I think only if they wouldn't solve G and somebody would solve everything. That's the only chance, because by the penalty they were the first one for long.
I love Team Kindergarten Time Limit. We had a training camp in Paphos in August, and they was there, and they performed very well. And they bring their own contest, which was also of this team. So I'm very happy for them.
Yeah, and they're super experienced. So yeah, we'll see how it goes. But for now, I think we should wrap it up for a bit, and thank you for joining us today. I think we have one more problem to look at the editorial. So we will now pause for a moment, and thank you, Pavel, for your advices, stories, and a little speech and just everything. So we will definitely want to see you next year again. So yeah, thank you for coming to us today.
Thank you. Goodbye, everyone.
And yeah, we will come back in a couple of minutes. And welcome back, everyone. We have a pretty busy end of a contest here in the live stream because we have one more guest, one more member of a jury who will tell us about one of the most challenging problems of today. It's a problem G. We don't know yet if anybody managed to solve it. We just know that there are a bunch of teams trying to do it, even our top 1, top 2 team, top 4 team. Maybe we will have somebody who solved everything, maybe not. We'll see that. But for now, let's discuss this problem for a bit. So now everybody who is watching, you can see the brief statement, and then I'm giving stage to you. So please tell us more about it.
Yeah, very gladly. So this is about these sort of sliding puzzles, which I feel like a lot of people should be familiar with on the principle of it. So in this one, the sliding puzzle can be rather large, so it can be up to 500 on either side. And so you're asked to find out whether it is solvable or not. And the reason why it might not be unsolvable is that some of the tiles are actually glued in place. So if you look at the bottom right, there's this image here where there's this green goo that's preventing 2 of the tiles from moving. And then the question is this actually still possible now that you cannot move the tiles arbitrarily? So yeah, that is essentially the problem. There's one more constraint in there, which is that each of these glue segments of the grid connects to the edge of the grid. So the one thing that cannot happen is that you have some tile that's glued somewhere in the center of the grid, and then all the tiles around it are free to move. So yeah.
And I think it's also guaranteed that if the tile is glued, that it's correctly placed. So like,
yeah, exactly. That is also because that would just be a very easy case. So we didn't want to have teams implement that because it is a very difficult problem anyway. So we try to make it relatively nice within the constraints of the problem, of course. Yeah. So that's the problem. I think to best understand and to explain, I should probably give some example, and then we can think about what are the possible.
Yeah, sure. We can use the whiteboard. There. Let us switch the stage. And yeah, I think you can use almost all of it. You can see here the small white sides that basically end, but yeah.
Okay, so let's see. Let's draw a small but not too small grid. I think 3 rows should be plenty, and then let's have these be sticky. Let's have this one not be sticky, have this one be sticky, and like this. Right, and so this one is always the empty tile. That's also guaranteed that the empty tile starts in the bottom right corner and it should end there. And now, so how can you move the tiles? And then, so if you think about it, so as you start sliding the tiles around, then this empty tile will move around the grid. And so an interesting situation is, how can you rearrange the tiles that are in this very leftmost part of the grid? So you need to move this empty tile somewhere here, right? And then at that point, whatever tile is here, let's say there's a number 7 on there, right? Then you will slide the 7 over here, and then the empty tile will be here, right? And then you can do some shifting around in there, but then once you're done with that, then the 7 moves back here, and you're back here, and then we can do some more shifts, move the tile back. So the story here is that this tile never can move to a different position. It's always fixed in place. And you can sort of do more analysis about which sort of tiles can even move. And then you will find that, okay, this tile is fixed in place. And then these 3 tiles, okay, you can shift them around somewhat. So we're sort of doing an upper bound here where we say, okay, which tiles could possibly change places? And then we need to do some more on top of that. Then it also turns out that these 3 tiles form one of these components, and then these 3 tiles do as well. And in general, to find these, there's a few different ways in which you can solve this. I think the one that is probably easiest to understand is in terms of biconnected components of the graph. So what you have here is that this square of cells, this is a biconnected component. This square of cells is also one, and then this vertex that is shared by them, if you think of this as a graph, this is an articulation point or cut vertex. And then whenever you have one of these cut vertices, then it always belongs to the component
which leads from that cut vertex to the root. So in this case, this cut vertex belongs to this component. This cut vertex here, well, this cut vertex here is on its own, and this cut vertex here belongs to this component. So yeah, so you need to put some graph theory in there, but that's not actually the entirety of the problem, because after all, it is one of the hardest problems. So then you need to think about what permutations can you actually achieve in there. And then I'm not sure, so I think this is sort of well known in the puzzling world, because it applies to all sorts of these puzzles. It applies to the Rubik's Cube, it applies to things like, well, the sliding puzzle. So the very famous one, and this was actually something, we looked this up, this puzzle first came out in the 1890s, which was the classic 4x4 grid, which is probably one you can find in many places, and it had all the numbers already in the right spot, except for these last two, which were actually flipped. And then there was a money challenge for, I think, $1,000, which at the time was, of course, huge amounts of money, right? For the first one to be able to solve this problem. Now, what do you think about this challenge? How did this challenge end?
Somebody did it or not? No. So there are some configurations that are not like shiftable.
Yeah. Yeah. So the reason no one ever managed to claim the prize money is because this is actually impossible to solve. And there's a well-known reason. This is the thing. This is called parity. If you talk about these kids that are into speed cubing, they will also know parity as a thing. So the thing is that whenever you swap two tiles here, then you also need to swap two tiles somewhere else. And so this one, where you just need to do a single swap, is just fundamentally impossible. And then the same applies to these individual components here. So formally, the thing that we're interested in is what's called an even permutation, which is exactly a permutation, so a rearrangement of the tiles that stems from an even number of swaps. And you can prove this to yourself because it's this grid. It's actually not that complicated to prove. You can do some sort of inductive arguments, but yeah. So these are all the things that you need to put together in order to successfully solve the problem. We will see whether any of the teams actually managed to do so. I think there was one submission before the freeze, which we do know was incorrect. And then I don't know how many submissions there have been in total during the freeze, but there's 3 blue squares in this column.
Okay, yeah, now I'm here, and I think there were 4 in total if we consider the company team. But yeah, only 3, but it's not 3 submissions, it's 3 teams who tried, because each of them tried more than once. But I think before the freeze time, we checked the code of some of those teams. I don't remember which exactly. I think it actually was University of Delft who didn't try this problem during the freeze time, but they tried it before, and they they were looking for double connected components and doing something on the top of that. So they are moving somewhere in the right directions, but obviously there are more stuff to figure out.
Yeah, there's a few tricky configurations in there. I think it's also allowed for the grid to be something like 1 by n. And that is actually relatively easy to solve because there's not much sliding you can actually do. But depending on how you code it, it might actually
be it was. I think we also checked the code for the jump trading team before the freeze time, and they had a wrong answer on exactly like this case because they simply didn't process the edge case.
I think we added this case at some. I think the original
it's like the late stage test. They passed like, I don't know, all of the complicated ones, and they just failed on a single row, not the column, but it doesn't matter yet.
Yeah. I mean, you have to watch out for. But I'm curious to see whether we managed to get a team that solves the entire contest. I don't think we have had this in NWERC in quite a long time.
Yeah, it would be definitely fun to see. But yeah, we have a couple of teams that have a great potential to do it. But I think only one right now, actually. I just expected more. I expected more submissions during the freeze time. But right now it's only kindergarten time limit who has a potential to do it. But yeah.
No, but this it looks like there's many different paths also to get into the top position. So
I'm
really happy with how this looks. It's going to be an exciting scoreboard reveal.
Yeah, for sure. With a lot of tries for those problems like B and G and I.
Yeah, maybe, I mean, I don't know for some of these submissions whether they were accepted. Maybe I might just not spoil myself and also keep myself in the dark.
Yeah, to have more excitement during the closing ceremony. Yeah, thank you.
Yeah, you're welcome.
Yeah, it like sounds like a complicated stuff. Like, I don't know, maybe it sounded for viewers like awesome, like you came up with this and that with that, and sounds obvious, but it's, I think, completely tricky to came up with all those
I mean,
things.
I think none of these steps is super complicated. It's just there's so many of them. So
yeah, it just doesn't look like
that's what makes hard problems hard.
Yeah, it just doesn't look like a problem you want to work on if you definitely before you solved other ones,
right?
At least most of other ones. So yeah, but we'll see how it goes on the closing ceremony. Thank you for joining, and good luck on the closing ceremony. I hope that somebody will solve it.
Yeah, we hope so too. Right? We don't put problems on there for them to go unsolved. So
yeah,
I'm happy if teams actually manage to figure out these bugs that they had. I mean, if there's multiple submissions, then not all of them are going to be correct most of the time, right? So
most probably yes. Yeah, thank you. We will pause for a moment, and I don't know if we will come back or not, but maybe just for a bit for sure. So stay tuned for now.
Okay. That'll work.
And welcome back, everyone. And while our contest is over, we are still not over with our live stream. Right now, you can see only 2 of my guests, but there are actually 3 of them. We have the whole team representing the jump trading company, who are sponsors and who are participating in the contest at the same time as contestants. We don't know yet who are the winner, if you guys managed to do it or not. We maybe shouldn't spoil if you solved those problems or not. Now it's freeze time, we don't know anything yet. But yeah, I know also that you're like very, very experienced participants. Some of you are world champions. So tell us a bit more about your participation this time, why you are here. Maybe tell something about the programs for students, for talented people in your company, and how do you find this contest? Just everything you have on the top of your mind, guys.
Yeah, I guess it was very fun. So my personal ICPC experience is I started in 2010 and it ended up in 2017 when me and Ilya won the ICPC World Finals. So after that time, after the finals 2017, I didn't do like any competitive programming, any code forces, any coder. So it was like a bit unusual to like start practicing again. I started like about a month ago, and I mean it was very fun. Yeah, I guess like on this contest there were like 10 relatively easy problems and like 3 super hard problems. And yeah, I don't know. We enjoyed the problem set. I think it's quite an interesting one.
Yeah, 10 are easy if you are a world champion maybe, but yes, still we have a lot of teams who solve at least 8, so 8 may be kinda easy anyways, but anyway, they were like with a broad selection of different topics and algorithms, which was pretty fun, I believe, for all of our competitors, participants, sorry. So yeah, but tell us a bit more maybe about jump trading. I don't remember if you guys were sponsoring last year NWERC, or it's the first year the company is sponsoring. I don't know.
Yeah, I think this is the first year Jump Trading is sponsoring this event. And we enjoyed it a lot, yeah.
And so you're looking for new team members for the company?
Yeah, of course. We did this company fair event yesterday, and everyone could attend it and talk with us about like some opportunities and how does it feel to work in jump trading. Of course, like I think we can say that we like it a lot.
Yeah, also so you have a pretty nice merch downstairs, so if anybody is here and still didn't grab it, yeah, you can join. Yeah, you're really giving those sweaters also to participate?
No, this is our exclusive ones.
So you need to join the company to get one?
Yeah.
So does it help you at work, the experience at ICPC, the high level that you get?
It helps you in a sense that you have some experience with like writing code fast and writing without like a lot of bugs, and like you can like debug the code without like running debugger or just by like reading the code and like trying to analyze the mistakes. The algorithms themselves, it's hard to find like any usage for them outside of competitive programming, but yeah.
I agree with what Vlad said. Like a lot of competitive programming algorithms are not as used in like real industry as in competitive programming, but still you have a lot of benefits from being able to prototype stuff quickly, and also you're used to write like optimized and efficient code a lot. So in competitive programming, you should often think about like how to write code fast, because otherwise you will get a lot of time limits, and that's what is useful in real world as well.
Yeah, kind of agree. I also think that the important part is like kind of abstract thinking and this stuff that you manage to store the super complicated constructions in your mind and discussing it with people who just understand you almost immediately, and you can collaborate really quickly. This is also something very important, because sometimes even if you sometimes talk with some software engineer and trying to explain him some approach to implement something, they're not understanding you because they're like not familiar just with that structures and how everything is stored. So you got what I mean, I hope. Okay, we can also turn on some scoreboard. It's freeze now, but we can just check the results because our contest is officially over several minutes ago. I mean that we don't have results, but sorry, it was a communication with our backstage to check that everything is fine. But we don't know the actual results yet. We can only see those yellow submissions, and we can only speculate would it be solved or not. So guys, without knowing if you managed to solve it or not, what do you think? Would there be any team who solved everything?
I mean,
except you, let's say.
There are certainly some chances because this team that is currently in number 1 spot, they finished the 12 problems, I believe it's 210 minutes or something like this. So they had 90 minutes to solve the last problem. So I mean, it's a good chance that they did it. 90 minutes is a lot of time if they had the solution.
Yeah, that would be crazy because as we were told before, it was a lot of years in a row without having a team which would close all the tasks here at NWERC. So yeah, it would be fun to see. We also have 2 teams from the same university in the top 3. We also have teams from different regions who will be definitely fighting for the top 3 places and the place in the world finals. So it would be nice to have teams from different sub-regions. Yeah.
Yeah, and for us it was super fun to participate with some real strong competitors.
Yeah, but it's crazy. You said you are not doing it for 5 years and you still managed to be at the very, very top of our table. We were constantly seeing you in the front lines. So it's just crazy how you can I say that working in jump trading helps you to keep your level of solving super hard, challenging problems on a high level?
I wouldn't say it helps your competitive programming skills, but it keeps your mind sharp. You're constantly solving problems. They are different kind of problems. They have nothing to do with competitive programming, but you're still very used to solving problems.
Yeah, I believe it should sound exciting for our participants because obviously if they like to just challenge themselves and try some tricky stuff, they should be also interested in working in something like that.
Yeah, it's a great place to work. Highly recommend.
So guys, is there anything else you want to share with us? Maybe you will join also next year. What do you think as sponsors, as participants, as a company?
We don't know yet. We would love to come again here because, yeah, as mentioned, it was very fun experience. But yeah, it doesn't completely depend on us.
To make plans a year in advance.
Yeah, but the preparations already started. We heard that the organizers are here for the next year and they're already working on it. So yeah, they should probably keep an eye on you. And
we'll do our best.
Okay, so I think we will wrap it up. Thank you guys sorry for having just a short discussion, but I believe you were very busy solving the problems, and still thank you for coming. So we will wait for you to join us also next year, and yeah, we'll see how it went with the scoreboard. If you manage to be the top team or not, we'll figure it out soon. So thanks everyone to joining.
Thank you for having us.
Thank you.
And just quickly wanted to say before we really go that this is probably would be the end of our live stream. So I also wanted to say thank you to all of the great team working behind, to Nikolai, who was helping me a lot today, to our great team in the backstage, Peter and Yoshi. You are the best. You are doing a great job. We also have a great team of volunteers, jury, and everybody participating in it. So just thanks, everyone. We'll have the closing ceremony soon, so stay tuned. And yeah, see you next year.